Morning to all of you. Very good morning. Good morning, good morning, good morning. I hope you people are doing good. And okay, what happened? Some other sounds were coming. Give me a minute. Now, okay. So now there won't be any disturbances. No. Okay, now let's start our session today. Yes. So yes, so we have completed up to the backfill up to yesterday's class. And now, um, first let's go with the remaining things and then we solve the questions also today. The last topic in this chapter is, now let's come to the last topic. Coulomb's wedge theory. So the last topic in this chapter is Coulomb's wedge theory. See, I'm telling you one more point here itself. See, based upon this theory, there were no questions asked in GATE regarding to the numericals, and same as with the ESC also. But in ESC mains, for the ESC people, in mains we are going to discuss this theory elaborately. But right now, for the GATE and IES prelims, this chapter means this topic is just you need to know what is what. That's it. And how you are going to compare this Coulomb's theory with the Rankine's theory. So beyond those points, you don't need to go for any other things. So listen to me first. This Coulomb's theory, again, soil is dry and cohesionless, as we assumed yesterday, the same way. Give me a minute. Okay, fine. So soil is a dry and cohesionless, just like Rankine's theory. In the case of the Rankine's theory, same. Soil is dry and cohesionless. Same with the Terzak means Coulomb's theory also. In Coulomb's theory, soil is dry and cohesionless. Apart from that, the common assumptions are homogeneous and isotropic. So, and then in the case of the Coulomb's theory and Rankine's theory, the basic difference is in Rankine's, I assumed back of wall is smooth and vertical. Just go back. You see, back of wall is smooth and moreover, you know, whatever the cases I have taken, everywhere, the back of wall is going to be vertical or not? Yes or no? You see, anywhere so far I took the back of the wall is a vertical face and the inclined face I have taken in the outside of the wall. So, in the case of the Coulomb's theory, the difference you are going to see as back of wall is rough, comma, inclined or vertical. See, the back of wall can be inclined or vertical. And moreover, that back of wall is going to be rough. See, in the case of the Rankines, back of wall is smooth. And in the case of the Coulomb's, back of wall is rough. When the back of wall is going to be rough, wall friction delta exists. Wall friction delta exists. So, and delta average is nothing but 2/3 of the phi. What is meant by 2/3 of phi? Phi means angle of internal friction. So the average delta for the ordinary retaining walls is a 2/3 of the phi. So we are going to get 2/3 of phi. So now, apart from this, so these are the major. One is soil is dry and cohesionless. Back of wall is going to be rough. And now, in the case of the Coulomb's, we are going to call it as wedge theory. Whatever the failure soil wedge is assumed as a rigid body. Failure soil wedge is assumed as rigid body, and apart from that, see, backfill surface is going to be planar. Same things. Backfill surface is planar. Plastic equilibrium occurs, and failure plane is going to be planar. See, the remaining three are going to be same. In Rankines and Coulomb's, the remaining three are going to be same. So backfill is going to be planar, means it may be horizontal and inclined. And the failure plane, whatever the failure plane we have been showing, right? What is this? This is critical plane or failure plane. This is going to be the planar also. So now, this is the biggest differences. Back of wall is rough and failure soil wedge is going to be assumed as a rigid body. So what is the meaning of this? Failure soil wedge is assumed as a rigid body, sir. Now let's see. So, you know, this is nothing but a retaining wall, or let's say, see, this is a so far I have taken. Back is going to be vertical. But In the case of the Coulomb's theory, you can take the back of the wall as inclined also. You can take the back of wall as inclined also. How, sir? No. Okay. Yes. See, whatever the representation, this is vertical back and this is a inclined back. Inclined back. So the back of the wall can be either vertical or inclined. So you don't need to worry about whether it's going to be only vertical or only inclined. You can take whatever you want according to the Coulomb's wedge theory. So now, what is meant by rough, sir? Rough means there is going to be a friction existing between the wall and the soil, and that is going to be delta. So now you see whatever the failure wedge, where is the failure wedge? We know this is nothing but the failure wedge armor. So you know this is nothing but the failure plane. These are going to be the failure plane, and this is nothing but soil wedge. So you are going to take this entire soil wedge as a rigid body, which means you take the whole soil mass at a time. In the case of the Rankines, elemental analysis. Sir, what is the meaning of elemental analysis, sir? In the case of the Rankines, I have been discussed that, see, for every case of the active or passive, what I have done is, you see, I took an element. This is an element, right? Passive state. And you see, active state, I have taken an element. So, in the case of the Rankines, the analysis is going to be done by taking an element, whereas in the case of the Coulombs, you are going to take the whole soil wedge as a rigid body. The whole soil wedge moves downward or upward based on the wall movement. That's it. You don't need to go for any formulas over here. The point that you want to consider over here is what is the basic difference between Rankines and the Coulombs is, you see this delta. And what is the effect of the delta? Let's have a look. According to Rankines, according to Coulombs, according to Rankines and according to Coulombs. See, the difference between the Rankines and Coulombs is, in the case of the Rankines, is there any wall friction? No. When there is no wall friction, the active force is going to be act exactly parallel to the slope surface. Means this is going to be the backfill inclined surface or not, means whatever the horizontal surface. So exactly the active force is going to be act, and it is going to be act at a height of h by 3. So it is going to be exactly horizontal, but now there is a wall friction. Due to wall friction, now the active force is no more horizontal. This active force is going to be make an angle of delta. What is this delta, sir? Delta is nothing but the wall friction. Delta is nothing but the wall friction. So now, in the case of the Rankines, this is active force. And in the case of the Coulombs, this is the active force. Now you tell me, if I take whatever the horizontal component of this one, what is the horizontal component? Fa cos delta. See, whatever the side next to the angle is nothing but cos. You know that. And mind it, here also it is going to be act at a height of h by 3 only. So the height is going to be act at a height of, means the forces are going to be act at a height of h by 3. But in the case of the Rankines, as there is no wall friction, this is Fa or this is Pa, means active pressure or active force. What is meant by Fa? Active force or active thrust. And in the case of the Coulombs, due to wall friction, then Fa cos delta. Sir, when can the Rankines and Coulombs are going to be same, sir? When can the Rankines and Coulombs are going to be same? If there is no wall friction, think, if delta is going to be 0, then Fa cos 0, 1 means Fa will be same. So when there is no wall friction, then Rankines and Coulombs both are same. But if there is a wall friction, Rankines is different and Coulombs is going to be different. So now you tell me, out of Rankines and Coulombs, which value is more? You see here, what is this horizontal? Fa. What is this? Fa cos delta. So Fa is more than Fa cos delta. Sir, why it is going to be more, sir? Sir, what is cos 0, sir? 1, sir. And what is cos 30, sir? 1 by 2, sorry. What is cos 30, sir? Root of 3 by 2. And what is cos 60? 1 by 2. What is cos 90? 0. As the delta value increases, the cos value decreases. As the delta value increases, cos value decreases. And Fa into cos means less than Fa or not. Now, my dear students, what I want to say here is, if there is a wall friction, due to wall friction, what happens here is, the active force initially Fa become Fa cos delta in the case of Coulomb. So active force is going to be decreases. So I can write the conclusion as, due to wall friction, active force decreases, and vice versa. See, you know that if active increases, passive is going to be decreases. If active decreases, passive is going to be increases. Opposite, right? I told you earlier, Ka is inversely proportional to Kp. If active increase, passive decrease, active decrease, passive increase. So due to wall friction, Fa active force decreases and Fp is going to be increases. Okay. Sir, in Coulomb's wall is inclined, no sir, but you written, Ray Baba, I wrote inclined or vertical, both. It can be vertical or it can be inclined also. But in the case of the Rankines, it's going to be always vertical. Now, that's all with this. Sir, which is more accurate? Rankines is going to be more accurate. Rankines is going to be more accurate than the coulombs. Rankines is going to be more accurate than the coulombs. Why, sir? See, the coulombs has some problem with the limiting equilibrium conditions. I'll write those points also. Rankine method is more accurate than Coulomb as Coulomb has problem with limiting equilibrium. See, while you're taking the equilibrium, right, the plastic equilibrium condition, there is some problem in the coulombs. So you don't need to worry about that problem, but Rankine's method is going to be more accurate than the coulombs. And moreover that, there are some other graphical techniques. So they are like Kalmans and Rebans. Rebans methods are graphical approaches based on Coulomb's wedge theory. See, in your BTech, you usually go with the Kalmans and Rebans graphical procedures, and I'm telling you that's a very, very tedious process. Means it's going to be long time taking, and moreover that the results may be fluctuating also. So generally we go for the Rankine's method. Actually, I'm telling you, the first method was Coulomb's. The first method was Coulomb's because around 1775, means in 18th century, Coulomb has proposed. And later on Rankine came. This theory came around 1775 and Rankine came in around 1856, which means Coulomb's wedge theory was developed in the 18th century. Rankine's theory was developed in 19th century. Now you tell me which theory is going to be more suitable. Whichever that comes later, they can remove all the alterations and a tedious procedure. So Rankine's is more accurate than the Coulomb's, and you know that where to use the Rankine's and where to use the Coulomb's. Now you see, whatever this is nothing but a masonry wall or not. This is a masonry wall. This is a masonry retaining wall. So as it is a masonry retaining wall, you can see this rubble masonry or stone masonry or brick masonry. You take any masonry structure. The back of the wall is going to be rough. Rough wall, which means delta exists. So this is going to be used. I mean, whatever the theory we are going to use for this wall, we use Coulomb's theory for analysis. See, you see, this is one wall, which is a masonry retaining wall, means made up of stones or rubble masonry. Rubble means a huge rocks or debris of rocks. And as this wall has a roughness, then delta exists. Then you are going to use the Coulomb's theory. But you see, this is a cantilever retaining wall. Cantilever retaining wall, which is a pre-stressed concrete. See, this is a pre-stressed concrete or not? Whatever this, I hope right now, whatever the retaining walls you are seeing, you can observe in this fashion or in this fashion. Whatever the retaining walls for the bridges, abutments, are you going to construct with the stone masonry or this one? This is going to be cantilever. You see, there is a reinforcement inside. This is nothing but cantilever retaining wall, Nana. Cantilever. So whatever, this is nothing but the stem portion. Whatever, this is nothing but the stem portion, and he's going to be the heel portion. So this is known as cantilever retaining wall. So in the case of the cantilever retaining wall, back is smooth. So now you tell me, when the back is going to be smooth, what type of theory you are going to over here? Rankine's theory. See, in the case of cantilever retaining walls, we use the Rankine's theory, and in the case of the masonry retaining walls, we use the Coulomb's theory. So we generally prefer the Coulomb's rather than the Rankine's. And these are the points that you need to look over. And last one more note point. Due to compaction. See, last one more note point. Due to compaction, think and say, what happens to PA and PP? Tell me. Due to compaction of backfill, think and say, due to compaction of backfill, what happens? Due to compaction of the backfill, when the backfill gets compacted, the angle of internal friction phi increases. Yes or no? So due to compaction of the backfill, angle of internal friction phi means the friction between the particles is going to be more. You know that. So while you are going to compact, the particles will slide over and more particles will be get interlocked. So frictional strength is going to be increases. So, and you know that if phi increases, Ka will decrease and the Kp will increase. Why, sir? You know, sir, for phi 20 degrees, what is Ka value? 0.49. For phi 30 degrees, what is Ka value? 1/3. And what is Kp, sir? 1/Ka. So due to compaction of a backfill, angle of internal resistance or angle of internal friction phi increases. So when phi is going to be increases, Ka, coefficient of earth pressure, decreases, and passive coefficient of passive earth pressure increases. Now you tell me, I can write due to compaction, active pressure Pa decreases and passive pressure increases. Active pressure Pa decreases and passive pressure Pp is going to be increases. So with this, we have concluded each and every point in this chapter. So just have a look. See, you don't need to worry about the analysis of the Coulomb's wedge theory. Don't go much into that. Whatever I said, this is sufficient. That's it. You don't need to go for any other things. So just you go through these points. That's it. Don't look into any other formulas of Coulomb's. I'm telling you, it is not at all important for GATE. And for IES mains, there I am going to discuss about the, for mains topic, the elaborative of this one. Sir, stationery is over. Tell Ace to send a pen, black, red to blue also along with the books, please, sir. Sir, is there anything that you required, sir? Any white paper, sir? Along with the chair and table and all those things, sir? कहाँ से आया रे भाई? Rishikesh, geostatic stress is active earth pressure or sigma? Arey Baba, geostatic means vertical stress. And due to that, whatever the pressure applied on the wall is lateral stress. What about design? See, in the soil mechanics, we are not going to discuss about the design. In reinforced concrete, RCC. So this retaining wall is similar to the gravity dam. This retaining wall is going to be similar to the gravity dam. Sir, which method is used in the field applications now? As I told you, Rankine's method is going to be useful now. Sir, why PP is absent in the partially submerged fill? Array, if you have a, see, I told you, it's not absent, Nana, it's not absent. I have explained you active and passive in dry and submerged. So now I am explaining the PA. Okay, I'll write over this one. Find similarly for PP. There is no absent over here. Don't think sir, passive condition you have not discussed. I told you that instead of Ka, if you keep Kp, that is going to be passive. Sir, as a civil engineer, we have to select the material. What is the procedure while designing? My dear anonymous attendee, this design is going to be discussed in RCC. What is meant by limit equilibrium? Limit equilibrium means plastic equilibrium over here. Sir, assignment I did not get, sir. Sir, see, I was busy with some other works also. I was having some other technical works. So because of that, and I was busy in preparing the test series questions also. And in the today is the 29th, right? Probably tomorrow or day after tomorrow, we are going to be upload a test series on the geotechnical. Means in your the login details would be provided later. I hope that you can contact the AS management, but so I was busy in preparing the questions for the test series. So that's why I did not give you the assignment. So probably tomorrow, today or tomorrow, I can give you. Sir, will you explain Kalman's and Dravan's theory? No, I'm not going to explain. Okay, fine. So I hope that's about Coulomb's and Rankine's theory. So now let's see the questions. I have asked you to solve this question yesterday. See, the whole points that you need to remember from the starting. I'm giving a quick review within 5 minutes. So you please look over these conditions clearly. I'm telling you again, 5 minutes. This entire chapter is over here. I'm going to give you a review. Look, first of all, earth pressure theories. So you know this earth pressure theories. If you are still busy in asking questions, then it's up to you. If you don't want to listen to this, then it's fine. So now, you know that you see this is a slope, and whenever a slope is going to be more than the safe slope, then it is going to be critical slope. And if you rise the slope beyond the critical slope, then the soil is going to be moved downward, and this is going to be the failure range. Okay. So now, if you take any point or any element over here, on that element there is a vertical stress and there is a lateral stress, and that lateral stress is going to be not is equals to vertical stress. So sigma h is equals to k into sigma v, where k depends upon the moment of the wall. And these were some of the examples I have given you for active state at rest condition. And now in the case of at rest condition, at rest means no movement of the soil mass and no movement of the wall and no yielding, means the soil is going to be restrained from the movement. As it is restrained from the movement, the strain is going to be 0. So then by using the equilibrium, elastic equilibrium condition, this elastic equilibrium condition, we can use the elastic constants, Poisson's ratio and Young's modulus. So we can write over, see, I said the mu is going to be Poisson's ratio over here, where K naught is equals to mu by 1 minus mu, or you can write as 1 minus sin phi. And active state, as the wall is going to be move away from the backfill, now the soil tries to move downward. When the soil tries to move downward, now you see, when the soil tries to move downward, resistance will act upward. Soil moving downward, resistance act upward. And this resistance will stop the movement of the soil, so that the soil exerted less pressure on the wall. So this is the wall and this is the soil. If the wall moves, then you see the gap between the wall and soil creates, then the pressure exerted by the soil on the wall is going to be decreases. Lateral pressure exerted by soil decreases up to the maximum shearing resistance. So in the case of the active state, major is vertical and minor is horizontal. Why? When wall move away, lateral pressure means horizontal stress is going to be decreases. So minor is horizontal and it attains an active state. And what is the angle made by the failure plane with respect to horizontal? 45 plus 5 by 2. Similarly, in the case of the passive state, so in the case of passive state, when wall move towards, it is going to be exert pressure on the soil. Now the soil will move up and resistance will be down. So here, due to the wall moving towards the soil, then the lateral resistance is going to be more. So the lateral pressure is going to be increases, then vertical pressure up to reaching plastic equilibrium. So in the case of the passive, who is major? Lateral. Who is minor? Vertical. And what is the angle made of failure plane with respect to horizontal? 45 minus 5 by 2. And what are the examples for this one, sir? So the examples I have given you, in the case of the sheet pile walls, beneath this is a dredge line. Whatever, there is nothing but the dredge line, the ground line. So the bottom of the dredge line, there is a passive, on the top is going to be active. And at rest condition, I have given you examples as basement slab and bridge abutments. And then we discussed about the Rankine's theory. According to Rankine's theory, we have find out the K naught, Ka, Kp. K naught as 1 minus sin phi, Ka 1 minus sin phi by 1 plus sin phi, and Kp is going to be inverse. Out of all, K is going to be less than K naught is going to be less than Ka, Kp. And the active pressure is going to be very less, passive is going to be very high, and the strain required to create the active is going to be very less than the passive. And then we discussed about the different type of a moist backfill. See, the point is, what I want to say here is, whether it is active or passive, it depends upon Ka and Kp only. It depends on K and Kp only. So now, in the case of the K and Kp, Ka is going to be less, Kp is going to be more. So I showed the pressure distribution more in the case of the passive. And what is the forces are? Area of the pressure distribution, half Ka gamma H square for active, half Kp gamma H square for the passive. So in the case of the submerged fill, what you need to look over here is, here hydrostatic pressure is same in all the directions. K and Kp are not applicable to the gamma W into H. So for the hydrostatic pressure or pore water pressure, don't apply Ka and Kp. Apply Ka and Kp for only effective stress. So K and Kp are applicable to effective stress only. And then in the case of the partially submerged, case A and B combined, we discussed about that. Ka is going to be applicable for only effective stresses, not for the total stresses. And if there is a surcharge, I told you the now third one. First one is going to be how to find out Ka and Kp. Second one is going to be, if there is a water table, apply Ka and Kp for effective stress only. And third one, if there is a backfill, due to surcharge, vertical stress increases by Q, lateral stress increases by K into Q. If it is active, Ka into Q, passive, Kp into Q, at rest, K naught into Q. And then stratified. Now here the stratified is, whenever I discussed about the stratified, means the interface, at the interface, first you find out the sigma V, and just above interface, whatever the soil, Ka1, just below the interface, whatever the soil, Ka2 into sigma V, that's it. And I have included all the conditions. There is a surcharge, there is a water table, there is a moist condition, and this is a submerged condition, and there is a stratified deposit. Everything has been included over here. Now, you know how to find out the location also, because the trapezoidal location is going to be x b plus 2a by b plus a into h by 3. And then we discussed about the inclined backfill also. See, generally, the possibility of asking a question on the inclined backfill is going to be very less. They cannot be asked for the numerical type. They can ask as a conceptual type. They can ask you what is Ka and Kp. So you can go through this one. And in the case of the C5 soils, So the difference between the C5 soil and Phi soil is this portion, 2C root Ka. Due to cohesion, active pressure decreases by 2C root Ka and passive pressure increases by 2C root Kp. And coming to the analysis of the C5 backfill, so by applying these two conditions, I can draw the pressure distributions, and I got to know passive I don't have any problem. But in the case of the active, up to certain depth, delta ZC, up to certain delta, up to certain depth delta, up to certain depth ZC, there is a negative pressure, and that negative pressure is due to tension, which causes a crack known as a tension crack. And how to determine the ZC? As at Z is equals to ZC, the active pressure is going to be 0, so that you can find out the tensile crack depth as a 2C by gamma root Ka. And if I apply such charge, how much crack depth is going to be decreased as Q by gamma. And what is the amount of such charge required for no tension at all? 2C tan alpha F. And what is the unsupported depth of excavation? 2 times of ZC. And active force before the formation of crack and after the formation of crack. Sir, in examination, if they ask active force, just simply you take after the formation of crack. And if they don't mention anything, you take after the formation of crack, neglect the tension zone. When you neglect the tension zone, how much active force is going to be increases? 2C square by gamma. And then we discussed about best suitable backfill as a cohesive soil or cohesionless soil. Cohesionless soil. And then we discussed about the Coulomb's wedge theory. So the Rankines is going to be more accurate than the Coulomb's. And where to use the Rankines? Cantilever wall, where the back of wall is going to be smooth, and masonry walls, then whether it is stone masonry or rubble masonry or brick masonry, you are going to use the Coulomb's theory. That's about. Now let's come to the. So I have asked you to solve this question. Now let's see how many. I'm going to apply everything over here. There is a C and there is a phi. Okay. Now let's see. First one, estimate the total active thrust on the back of a rigid retaining wall. Neglect effect of the tension zone. And see, they are saying that clearly neglect effect of the tension zone. What is the meaning of neglect effect of the tension zone? After the formation of crack. Just now I mentioned you, if I say neglect the effect of tension zone, then that is nothing but the after the formation of a tension crack. And that assume that there is no friction between the soil and wall, which means Rankine's theory. So as there is no friction between the soil and wall, back of wall is going to be smooth. Take unit weight of water as gamma W 10. Now let's see. There is a cohesion R naught. Everybody have a look. There is a water table. And is it a homogeneous deposit or stratified deposit? Stratified. Above it is a clay, because you see phi 0 and C is there. Below sand. Sand means C is equals to 0. So now we need to find out the what we are asking. What they're asking is a total active thrust. What is the meaning of total active thrust? FA. So if you want to find out the FA, first of all, you have to draw the pressure distribution. So now everybody, at the top of wall, first one, at the top of wall, what is the vertical stress, please? Vertical stress is going to be 0. But what about the lateral earth pressure? You please observe, I am asking you at the top of the wall. So as it is a stratified deposit, now given is phi 1 is going to be 0 degrees, which is nothing but K1 is equals to 1. And phi 2 is equals to 30 degrees, which is nothing but Ka2 is equals to 1 by 3. So I told you, if there is a layered deposit, wherever you are finding, at that point only you are going to take out the Ka value. So now I am going to discuss about the top of the wall. So I can write Ka1 sigma V minus 2C1 root Ka1. Sir, why you are taking this portion, sir? Sir, whenever the cohesion exists, see, yesterday we discussed this question, right? Here, what is the cohesion? Here, this is going to be C0 because cohesionless soil. So, cohesionless soil, which means I can take directly C0, but here there is a C, right? Minus 2C1 root Ka1. So come on, please tell me what is Pa value? 1 into 0 minus 2 into C into root 1, which is going to be minus 10 kilopascals. And you know the meaning of the minus 10 is, you know that the meaning of the minus 10 is the tensile pressure. Okay. Now coming to the yet interface. Yet interface means this is the interface or not. First of all, you find out the vertical stress. Yet interface, find out the vertical stress. You see there is a water table, right? Then gamma sat into 3. I can write this one as gamma dash into 3 plus gamma W into 3. Okay. So now you have to take, whenever there is a interface, I told you just above and just below. Just above and just below, vertical stress is going to be same, but the lateral stress is Ka. Soil above, Ka1, soil below, Ka2. So now just above, Pa is nothing but Ka1 into sigma V minus 2C root Ka1. Yes. So now I can write directly this one. You know, Pa is equals to Ka1 into, and you know that when there is a water table, K is applicable for whom? Effective stress only. So gamma dash into 3 plus gamma W into 3 minus 2C1 root Ka1. So now you substitute the values. K1 1 into gamma sat how much? 20. Then gamma dash 20 minus 10 into 3 plus 10 into 3. And what about this value? What about this value? Already it is there or not? So minus 2 into 5 into root 1. So if you solve 60 minus 10, which is going to be 50 kilopascals. Similarly, just below, now Pa is equals to, when I say just below, you have to take the below Ka and below C value. See, if I go below, then the soil properties are going to be changes, right? So as a phi changes, Ka changes, C changes. So now Ka2 into gamma dash into 3 plus gamma W into 3 minus 2C2 root Ka2. You please observe, just above I took C1, just below I took C2. Just above Ka1, just below Ka2. So now you observe, in the case of the Ka2, you know that, what is the C value please? What is C2 value? 0. And what is Ka2? 1 by 3. So which means I can write, this is going to be 0. And 1 by 3 into 10 into 3 plus 10 into 3, which is going to be 40 kilopascals. 40 kilopascals. Okay. So now I got to know the now I got to know that, see, this is gamma 1 Z1. I have find out the vertical stress. Now at bottom of wall, what is the vertical stress I can write? I can write down the vertical stress as, you see, whatever this is gamma sat, gamma dash of clay into 3 plus gamma dash of sand into 2 plus gamma W into 5. Can I write like this? Can I write like this? You please observe, see, this gamma dash means 20 minus 10, right? 10. So now you see, just above, see, I am finding this is sigma V. At the interface, this is a sigma V. Now, while I applying just above, I'll write Ka value applicable. The Ka value is applicable for whom? Effective stress only. So if I write just above Ka1 into gamma dash into 3, if I write below Ka2 into gamma dash into 3, now you see, as I am asking you at the base, so above clay, below sand. So as it is a water table, I know that Ka value is going to be applicable for whom? Effective stresses. And you tell me, I am asking you to find out the stress at the base. At the base means should I have to use Ka2 or Ka1? Ka2. So Pa is equals to Ka2 into gamma dash of clay, means submerged pressure only, into 2 plus what is the total pore water pressure over here? What is the total pore water pressure? So you can write that, right? Gamma sat into 3 plus gamma sat into 2 can be written as gamma dash into 3 plus gamma dash into 2 plus gamma W into 5 plus gamma W into 5 minus 2C2 root Ka2. Okay, so now again C2 is going to be 0. So now please substitute this Pa value 1 by 3 into, you see gamma sat is given as 18 and you know gamma W, what is gamma W? 10. So gamma dash of clay 10 into 3 plus 8 into 2 plus 10 into 5. So please solve this one and 30 plus 16 by 3. This is going to be 65.33 kilopascals. Sir, just to be it should be gamma dash into 2 na, sir. Sir, how many times I say, sir, the same thing, sir? How many times I say the same thing, sir? Sir, the vertical stress I have find out, sir. Please go through this one, sir. Just whatever the interception you are having, please remove that one, sir. I am saying over here, sir, the vertical stress just above and just below is going to be same, sir. Changing is going to be lateral stress, sir. You apply Ka1 just above, sir, below Ka2, sir. So still you are asking the same doubt, sir. Sir, can we take the saturated unit weight? No, I told you Ka and Kp are applicable only for the submerged weights. This is the procedure. If you want to follow, you have to follow in this way. And if you take, sir, I will take gamma side instead of gamma dash, you will be out of coverage area. I have given you enough reasons and I have discussed the same topics n number of times. So now, once we got down the entire stresses, see, in the case of classroom, I don't go for just above and just below also. Directly I can draw the pressure distribution. Now we'll draw the pressure distribution. Let's see the pressure distribution. This is not the end of the answer. The answer has not ended yet. You see, this is the interface. Now let's see, at the top of wall, what is Pa value? Minus 10, means this is going to be 10 kilopascals. I am representing the minus on the left side. And now you come at interface just above, what is the value? 50, just above 50 kilopascals. Okay, and just below, what is the value? 40 kilopascals. And at the base, what is the value? 65.33 kilopascals. So these are the values that I got just above and just below. Now let's join all those things. You observe, this is 10 and just above is going to be 50. Just above is going to be 50. And what is just below? 40, right? Which means the stress is going to be decreased just below, and then from 40, here it is going to be 65.33. So this is how the stress distribution is going to be looks like. Now if you want to represent this clearly, I'll represent this clearly now. At the interface, see, please focus on the interface. Most of the people still asking the same doubts. I'm telling you clearly, please listen. In the case of the interface, the vertical stress is going to be same. Please don't write below as a gamma dash into 2. That the meaning is going to be entire changes. Think. If you keep your palm just below, if you keep your palm, the vertical stress is not going to be changes, right? But the lateral stress is going to be above Ka1, below Ka2. So I am not going to do anything. I just find out the sigma V first, and then I am applying Ka1, and then I am applying Ka2. So now just above it is going to be 50, just below this is going to be 40. So what we have done is we have developed the tension crack. We have developed this one, and I can say negative, positive. And you know that whatever the depth up to the tension crack exists is nothing but ZC. Now, my dear students, are you going to apply this value directly? Are you going to apply these values directly? If you do apply, you will be out of coverage area. Why, sir? Sir, I explained this 2C by gamma root Ka for whom, sir? Moist, sir, or dry backfill, sir. But whatever the condition I am taking, is it a dry soil? Water table is there. Is it a homogeneous? No, stratified. So don't use 2C by gamma root Ka everywhere. Please, I am telling you that 2C by gamma root Ka is for a homogeneous, and when there is no water table over there. So if there is a water table, then the things are going to be changes. So now you see, then how to find out this ZC, sir? See, the total height is going to be 3 meters, right? Then what about this one? 3 minus ZC. Finally, what we required is a FA. And is it after the tension crack or below the tension crack? After the tension crack means neglect the tension zone. Look, I want to neglect this zone. If I want to neglect this zone, first of all, I have to neglect. First of all, I have to find out up to what depth that is going to be happen or not. Now, can I write? This is going to be similar triangle. You please observe this portion, please. This is going to be the similar triangles or not. So now I can write from similar triangle. From similar triangle, you see for ZC, what is the value? 10. And for 3 minus ZC, what is the value? 50. So for the similar triangle, the slope is going to be same or not? See, this is slope and this is slope, both are same. The representation of double n is similarity. What is the slope, Nana? What is mean by slope? Y by x or not? So what is the slope over here? ZC by 10, y by x. And what is the slope over here? 3 minus ZC by, are you going to take 50 or 40? 50. Because you are discussing about above, not below. So now ZC by 10 is equals to 3 minus ZC by 50, which is going to be 6 ZC is equals to 3, and ZC value is going to be 0.5 meters. So now you are going to remove this 0.5 meters. Then what is this value? 2.5 meters. I hope you understood. What I have done over here is, Arey Baba, once you know the magnitudes, can't you find out the tension crack by similar triangles or not? Yes. From the similar triangles, simply the slope of this line, red line, y ZC by x 10. And for this line, what is y? 3 minus ZC by x 50. You can find out the ZC. And now, by neglecting the tension zone, by neglecting tension zone, if I neglect the tension zone, I neglect the tension zone. So I'm going to yes. these are the things that I am going to get, and this is 2.5 meters. And what about this? This is going to be 2 meters. I have shown you yesterday also. See, just simply neglect the tension zone. Once you neglect the tension zone, now you tell me whatever the force, let's take this as F1 and let's take this as a F2. So now the active force FA is equals to F1 plus F2. What is F1? F1 means area of the triangle or not, which means half into base 50 into height 2.5 plus trapezoidal 2 by 2 h by 2 into a plus b 40 plus 65.33. Then active force is equals to 167.83 kilonewton per meter. See, this per meter means per meter length of wall, because we don't know the actual length of the wall, right? So that's the reason why we took a per meter length. So now see, I'm repeating this question. First of all, what I'm doing is I'm finding at the top of wall and at interface, I'll find out the vertical stress first, and then just above I multiply with Ka1 C1, just below I go with Ka2 C2, and at the bottom of the wall I'm going to write down the directly Ka2, and you know the soil is going to be completely submerged, right? So gamma dash of clay into 3 plus gamma dash of sand into T. For that you are going to apply the K value, and plus gamma W into 5, no K value. As there is no C2, then you remove the C2, draw the plot. Then from the similar triangles, you can find out the ZC. And as they're asking, by neglecting the tension zone, so if you neglect the tension zone, this is the pressure distribution, and you can find out the active force by taking a above triangle, below as a trapezoid. I hope you understood. So solution is too long, how to manage time? See, I told you the solution is not too long. I can directly write down the values over here. If you are going to be practice enough, I don't need to write about the top of the wall, interface, and something like that. I can directly manage the values directly over here. Okay, I can write down the values directly on the figure itself. At the top, at this point, at the interface, just above, just below, and all those things you can find out directly. So the people who wants to go with the logics, right? If you want to go with the logic, there is no logic over here. The logic is you have to find out directly on the distribution. So now I'll give you at first, this is at top or not? At a top, sigma V is equals to 0, then PA is equals to whatever the value you are going to see over here. So as it is a cohesion, due to cohesion, what is this value? What is this value? Ka1 into 0 minus 2C1 root Ka1. So you need to find out. Now coming to the interface. Above the interface, then Ka1 into whatever gamma dash of clay into 3 plus gamma W into 3 minus 2C1 root K1, and just below Ka2 into gamma dash of clay into 3 plus gamma W into 3 minus 2C to root Ka2. And at the bottom, Ka2 into gamma dash of clay into 3 plus gamma dash of sand into 2 plus gamma W into 5 minus 2C2 root Ka2. See, the logic I do in the class is normally, this is the logic I just follow. I'll write down the values directly over here. If I write down the values directly over here, then I think probably you can understand much more better. I write down the interface just above, just below for the sake of your better understanding. If you solve, this is going to be minus 10. And if you solve, this is going to be 50. If you solve, this is going to be 40. And this is going to be 65.33. So now you can draw the distributions directly. 50. So this is 50 and this is 40 and this is going to be 65.33. I hope you understood. Yes. So ZC value coming same by using formula. So it may be coming now, but it is not going to be true for all the cases. I got 142 in another method. I did not say any other method. I said only one method. So if you have got, sir, you are going too fast. Array, I am going too slow because I said you these things n number of times. Okay, so kindly explain why did not use the formula of ZC, sir, please, sir. Okay, fine. Please observe. My dear fellow student, you see this ZC formula is suitable. This ZC formula is suitable in the case of this tension crack. If you observe, whatever this condition, have I considered any water table over here? The person who has asked me, sir, why you are not using ZC formula, have I used any water table over here? No. So if there is no water table, and moreover that, have I discussed about the stratified deposit or homogeneous deposit over here? Homogeneous. But in the given question, the deposit is a stratified layer. There is a clay and there is a sand. And moreover that, in the given question, there is a water table. Here there is no water table. So don't use ZC value directly. If you use ZC value, you may get the answer now, but it is not going to be true for all the cases. That's why I'm not using ZC value. And one more question, one of our students is asking, sir, yesterday you have added this one, but now you are removing that one. Baba, you see the question clearly. What I have drawn over here, Nana? After the formation of crack, I am removing the top portion or not? Yes or no? See, yesterday also I did not find out the forces. Did I find out the forces? No, because I told you if you know the magnitudes, you can find out the forces. So once I know the tension zone, means once I know the neglecting the tension zone, I'll remove the top portion. So I want this portion only, right? I remove the negative zone, then I find out the F value. So that FA is nothing but the FA2. That's it. And now you see, you go to the question. This is the one, right? This is the one. After the neglecting, this is the one that is going to be an active force. Okay. See, when I ask you a question, what is the increase in the active force by comparing before to after formation of crack, then it is going to be increases by 2c square by gamma. My dear student, those who has asked me, now you please find out before the tension crack, means by considering all these values, you please find out the value and you please find out this value. You will get it definitely the difference as 2c square by gamma. So that's about the questions. Sir, sometimes you take gamma and sometimes gamma dash. Why you take gamma dash here? I don't know. How many times I can say, Baba? See. Okay, as you want me, gamma sat of clay into 3 plus gamma sat of sand into 2. This can be written as gamma dash of clay into 3 plus gamma dash of sand into 2 plus gamma W into 5. That same gamma sat, I split it into gamma dash plus gamma W. Yes. So now that's about those conditions and okay, fine. So that's about this question. Now, let's see the remaining things. Okay. So now, some okay. Now let's come to the next question. This is the last question from this the classroom practice questions. From the classroom practice questions, this is the last question. Now let's see. So question number 3. A vertical retaining wall of 8-meter high is backfilled by 3-layered cohesionless soil. See now, the soil is going to be a vertical retaining wall of 8-meter high is backfilled by 3-layered cohesionless soil, which means the soil is going to be cohesionless. So now let's draw the figure. Now, please observe. So the total height is going to be 8 meters. And in addition to that, there is a surcharge. So there is a surcharge applied over here. How much? 40 kilopascals. And the surface layer is having an angular internal friction of 35 degrees. So this is a 3-layered, right? As it is going to be a 3-layered, so now the surface layer is having an angular internal friction 35 degrees and dry unit weight as 16 kilonewton per meter cube for a depth of 2 meters. Similarly, the middle layer is going to be having an angle of internal friction 40 degrees and dry unit weight as, this is gamma D1, 19.5 kilonewton per meter cube for a depth of 2 meters. Now, bottom layer is going to be submerged. What is the meaning of submerged? So the soil is under water table. You know that if I say submerged, then it must be saturated. That will be case below the water table only. So with having an angle of internal friction 3, how much? 30 degrees, and saturated unit weight I gave you as 20.5 kilonewton per meter cube. For the rest of the depth, what is the rest of the depth? 4 meters. Determine the depth. Now see the question they are asking. Determine the depth from the top of the wall. From the top of the wall where the active earth pressure is 80 kilopascals. So they are asking depth at which active pressure is going to be 80 kilopascals. My dear students, they are not asking you to draw the pressure distribution. They are not asking you to find out the active force. They are asking you simply one thing. That thing is where the active earth pressure, which means the lateral pressure is going to be 80 kilopascals. Now, My question is, listen to this point clearly. Do we know? See, we don't know where it is going to be happen. We don't know whether it happens in the first layer. We don't know whether it happens in the second layer. We don't know whether it happens in the third layer. Okay. So as we don't know in which layer it is going to be present, now the PA is going to be 80, can be here, or can be here, or can be here, because this is a 3-layer deposit or not. So as I don't know, I have to go for trial and error procedure. So now, my dear students, please tell me, where do you see the maximum active pressure? You see the maximum active pressure at the base, right? Yes or no? Because you know, with respect to the depth, vertical stress increases, so lateral stress is also going to be increases. I have given you a lot of variations, and where is the maximum you are going to see? You see, where is the maximum you are going to get? The maximum active pressure will be always at the base. Yes. So now this is the crucial point where you have to understand. The question is, they're asking the depth at which active pressure is going to be 80 kilopascals. No. Now, as we don't know where, means in which layer it is going to be fall, first I'll go with the trial and error, as I'll find out what is the pressure, active pressure at base. If I can find out what is the active pressure at the base, then I can know whether the 80 falls in the third layer or second layer or first layer. Let's see that. So first you find out the active pressure at base. The active pressure at the base is equals to, so come on, you see, is it a, what type of the soil mass? See, there are 3 layers. This is not a 2-layer deposit. There is a 3-layer deposit. So definitely this is going to be, what is this? Ka3. And moreover, cohesionless means C is equals to 0. So now first you write down the equation. So I'll write down as you want me, at base. First you please write down the vertical stress. What is the vertical stress at the base? You please write down the vertical stress at the base, please. What is the total? First one, gamma D1 into 2 plus gamma D2 into 2 plus gamma sat into 4. Gamma D1 into 2 plus gamma D2 into 2 plus gamma sat into 4. But you know that Ka is applicable only for the effective stress. Yes. So now what is Pa at the base? So the Pa is going to be, as I am looking over the third soil, then I have to take it as a Ka3. Ka3 into gamma D1 into 2 plus gamma D2 into 2 plus, now I am going to split this one as a 2 parts, right? Gamma dash into 4 plus gamma W into 4. You know that. So now you tell me, as this portion is going to be submerged, you have to apply Ka3 for whom? Gamma dash into 4 plus gamma W into 4. Okay. So now can you please tell me, as phi 30 degrees, what is Ka3? 1 by 3. So 1 by 3 into gamma D1, 16 into 2 plus 19.5 into 2 plus gamma dash. What is gamma dash? So they have given gamma W as 9.81. So 20.5 minus 9.81 into 4 plus 9.81 into 4. So after solving, I hope you get Pa value as somewhere. Okay, sorry, I did not consider the surcharge. I have to consider the surcharge. Sorry. What is sigma V? Sigma V is equals to Q plus. So now, sorry, I need to consider the surcharge. Pa is equals to Ka3 into Q plus. So this is going to be 1 by 3 into Q. What is the surcharge I have given you? 40 plus 16 into 2 into plus 19.5 into 2. So first we find out the vertical stress, and then I am applying the Ka value only for the effective stresses. So please tell me the values. So now, what is a PA value over here? If you solve, can you please tell me what is the PA value? The PA value is somewhere 90 point something. Let me calculate. 20.5 minus 9.81 into 4 plus 19.5 into 2 plus 16 into 2 plus 40 by 3 plus 9.81 into 4, which is going to be 90.49 kilopascals. So now, my dear students, first I find out the base and I got to know this value as 90.49. So now if you understand this topic, you can directly say, look, this is going to be total of 4 meters, right? This is going to be total of 4 meters, right? So the total of 4 meters. Now you see, I want to find out the depth at a pressure which is going to be 80. What is the pressure at base? 90. Then definitely the pressure PA is equals to 80 kilopascals will fall into the third layer or not, because as 80 is going to be very near to the base, and moreover this soil strata is going to be how many meters thick? 4 meters thick. 4 meters thick means then definitely the 80 will be falling in this layer. So now, as PA is equals to 80 kilopascals near to the base PA, so point main lies in third layer. Sir, how come you directly fix it third layer, sir? Now let's see, sir, I fix it third layer. Now when I find, if I get the value as a positive, then my assumption is going to be correct. Yes or no? See, I took first one, I made a trial, I just threw some stone in the water, and then I got to know this 80 may be present in the third layer. Yes. So now, as it is going to be present in the third layer, now let's find out whether it is in third layer or not. If I get a positive value, then whatever my assumption is going to be true. If I get negative, then I have to go for iterations. Okay. So now, as it is going to be third layer, now you tell me what is the lateral earth pressure. So can you tell me please? At third layer. Now PA is equals to 80 kilopascals. Yes. Then can I write 80 is equals to, now in the third layer, right? Ka3, because in the third layer, and let's take up this depth is going to be X. This is going to be X, because we don't know at what depth it is going to be there. And you know this is 2 meters and you know this is 2 meters. So now at this point, what is the vertical stress, you know, and you can find out the lateral stress. And I see I am writing the equation directly now. Please look. Ka3 into Q plus gamma D1 into 2 plus gamma D2 into 2 plus, now coming to the third layer, I have to apply gamma dash, and up to what depth? Are you going to take 4 meters or X meters? X. Gamma dash into X plus gamma W into X. So now instead of 4 meters, I am taking the X. At 4 meters, you are going to see it as PA. Now 80 is equals to 1 by 3 into 40 plus 16 into 2 plus 19.25 into 2 plus 20.5 minus 9.81 into X plus 9.81 into X. So find out the X value, please. Find out the X value. If you get, that is going to be 3.22 meters, I think so. And from top, you see they're asking what? Determine the depth from the top of the wall. So from the top of the wall, this is the Z. From the top of the wall, Z is going to be 4 plus X. So which means 7.22 meters. That's about this. I hope you understood the topics over here. So I have done all the questions. Sir, can we interpolate? No, we cannot interpolate. We cannot interpolate because this is not a homogeneous layer. So you cannot interpolate directly. Sir, why you added such as to only first layer? Sir, when to use F dash formula? Why to use F dash formula? You don't need to use any F dash formulas, Nana. See, this is just an analysis. Okay, don't think this as a formulas, Nana. Don't think this as a formulas. This is just for the analysis. I want to know what is the increase in the active force. So I have done this one, 2c square by gamma. Please you find out this F and F dash values. So remember one thing. I'll ask you a question. If you know the magnitudes, do you need to use all these formulas? No, you can find out directly, right? Once you know the magnitude, what is the force? Area of the pressure distribution. That's it, right? Mr. Corona, how many days to complete the subject, sir? I told you within a week we will be completed. So today we have means now everything is completed in the chapter number 14, but I have to solve some previous GATE and IS questions. That's it. And we will be starting the chapter number 11 now. Means sorry, we'll be starting the chapter number 15 now within a few minutes. Yeah, okay, fine. I'll take. Yeah, now after this subject, I'll take some 10 minutes of how to manage the tension. That's what most of the people are looking for. Some of the students like, see, I don't know. Whatever video is coming, right? Okay. So now I hope you understood this. So if you have understood this one, now let's see some of the other things regarding this chapter. Okay. Now, there is a previous gate question. Please look over this question. Look, a retaining wall of height 8 meters retains a dry sand. A retaining wall of height 8 meters retains a dry sand. So the given soil is going to be dry sand. So, and this is a retaining wall of 8 meters retaining a dry soil. Dry sand means there is no water table, right? In the initial state, the soil is loose and has a void ratio of 0.5. So initial state, initial void ratio is going to be 0.5 and gamma D is going to be 17.8 kilonewton per meter cube. And the phi value is going to be how much? 30 degrees. Now, subsequently, the backfill is compacted to a void ratio after compaction. After compaction, the void ratio is going to be, after compaction, void ratio decreases and gamma D is going to be increases. And I told you already, in the case of the compaction, when you compact, the angle of internal friction is going to be increases. Yes, you see before compaction 30 degrees, after compaction 35 degrees. I already told you due to compaction phi value increases. When phi value increases, Ka decreases, active pressure decreases, passive pressure increases. So wait for the moment, I'm going to discuss that. So now phi 2 is going to be 35 degrees. So the ratio of the initial passive thrust, what is means by passive thrust? Passive force. Look, they're asking passive, right? Now, generally, if I draw normally, this is going to be gamma and phi, this is going to be C. And you know, if I draw the pressure distribution, is there any water table? No. Is there any saturated deposit? No. Is it stratified? No. At the top, 0. At the bottom, Kp gamma H. So now you know whatever the force, this is Fp. Fp is equals to Kp gamma H square by 2. So you know that. How I have find out this one? Area of the pressure distribution. See, force is nothing but area of the pressure distribution. And what they are asking is, what is the ratio of initial passive thrust to the final passive thrust? So you know that first you find out initial Kp1. What is Kp1? Here 1 plus sin 30 by 1 minus sin 30. So which is going to be 3 if you solve. And what about Kp2? 1 plus sin 35 by 1 minus sin 35. So can you please tell me what is this? 1 plus sin 35 by 1 minus sin 35, which is going to be 3.69. So now, if you are using over here, so I am asking you the thrust Fp1 by Fp2, which is going to be Kp1 gamma 1 H1 square by Kp2 gamma 2 H2 square by 2. Yes, means I hope you understood this. By 2 by 2. 2 gets cancelled, and you see H1, H2 also gets cancelled because height is going to be same R naught. So Kp1 by gamma 1 by Kp2 by gamma 2. So Fp1 by Fp2 is equals to, what is Kp1? 3 into gamma 1, 17.8, because here gamma 1 means gamma D1 by Kp2, 3.69 into gamma 2, 18.8. Please find out this value. 3 into 17.8 by 3.69 into 18.8, which is going to be 0.769, which is going to be 0.769. So what is the answer over here? 0.7. See, I don't need to go for all these procedures also. I can directly say that, you see, height is going to be same. Yes or no? As the height is going to be same and 2 is going to be same, then force is going to be directly proportional to Kp into gamma. So Fp1 by Fp2 initial, Kp1 gamma 1 by Kp2 gamma 2. You know phi 1, you know phi 2, find out Kp1, find out Kp2. You can find out Fp1 by Fp2. What is the meaning of this one? Before compaction and after compaction. So you see, once you know the compaction, after compaction the value is going to be more. I told you, due to compaction passive force increases. Sir, how height is same after compaction? Sir, the height is nothing but height of the retaining wall, Nana. It is going to be, sir, is he used to fool us? Yes. See, the depth is not proposed. See, this is a retaining wall of height 8 meters, Nana. That's not a soil, that's a retaining wall of 8. So you are going to filling the soil up to the total height of the retaining wall. Okay, have a look once. Does my video is not visible to you? Okay, fine. So now let's see. Now this question, please look. When a vertical face of excavation was made into a clayey silt having a density of 20. So the density of the soil is given as a 20 kilonewton per meter cube. And it failed at an excavation of 4 meters. See, when you provide a vertical face of excavation, what is the maximum depth of excavation that you can do without any failure? This is nothing but the HC. See, up to HC, in the case of clays, up to HC, there is no failure. And what is the, so the failed at a depth of 4 meters, which means they have given the critical height as 4 meters. So where HC is going to be critical height. So height up to which excavation without support. See, you know that if you go beyond HC, then what happens? If you go beyond HC, what happens? Then definitely the pressure is going to be there or not. So with that, then the excavation may fail. Then you require a support. See, up to HC, no force, no support. And beyond HC, there is a force, then you require support. So now, whereas there is no support, it is going to be failed beyond 4 meters. What is the cohesive strength? C value, if phi is going to be 30 degrees. You know that HC is equals to 2 times of ZC. There is no such charge. So as there is no such charge, I can write ZC as a 2C by gamma root Ka, which means 4C by gamma root Ka. So you know that Ka is going to be 1 by 3. So I want a C value. You please find it out. 4 is equals to 4 into C by gamma is how much? 2 into root of 1 by 3. So find out the C value, please. So 4 gets cancelled, and if you find out the C value, 20 into root of 1 by 3, which is equals to 11.54. Answer C. So this is ESC 2009. Answer is going to be C. Who said if cohesion is more then the friction is more? I did not said if cohesion is more and friction is more. Cohesion is different and friction is different. Sir, how to calculate without calculator? So now you see, sir. Sir, just simply you look. See, without calculator, how can I solve this? Without calculator, how can I solve this? See, 4 gets cancelled or not? Then what is C? 20 into root of 1 by 3. Okay. 1 by 3 means 0.33. Yes or no? 1 by 3 means 0.33. So this 0.33 can be written as a root of 0.33. See, wherever you see root value less than 1, then the root of, for example, let's take a root of 0.75. Then it is going to be more than 0.75. Root of 0.33, more than 0.33, then it is going to be the root of 1 by 3 is going to be just more than 0.5. Just more than 0.5. Yes or no? The root of 1 by 3 is going to be just more than 0.5. So 20 into just more than 0.5, which is going to be 11.6, means nearby. This is 10.2, means exactly at 0.51. So 20 into 0.51, that is going to be that value. But as it is going to be root of 1 by 3, you can eliminate first these two options. 20 into root of 1 by 3, you can eliminate these two options. The answer lies between these two. So if you use your brain clearly, then you can get it as a 11.6 without using any calculator. No, that's ESC. ESC means 2 marks questions only. So in the previous questions, we can use the relation between E and H and find the height of soil after the compaction. No, Nana. This is, my dear student, what happens over here is, look, what is that question? Yeah. See, that's a height of the retaining wall, not the soil. Can you compact the retaining wall? Can you compact the retaining wall? So that's the reason why I said this throughout this 8 meters, you're going to fill the soil. I'm not saying 8 meters of soil. I'm saying the retaining wall is 8 meters. So the retaining wall height is not going to be changed. So Mr. Nikhil, I hope you understood now. Now, you see, for a cantilever retaining wall, Rankine's theory of earth pressure may be used. Yes, I told you for cantilever retaining wall, you see, for cantilever retaining wall, Rankine's theory is going to be used, and for masonry wall, Coulomb's theory is going to be used. Yes, for a retaining wall with a smooth vertical back, Rankine's theory is going to be appropriate. So cantilever retaining wall has a smooth back. So when the back of wall is going to be smooth and vertical, then you can go for the Rankines. So statement number 1 is true, and statement 2 is true, and statement 2 is a correct and appropriate statement for 1. So answer is going to be A. Answer is A. Now, see this question. This is a ESC question only. Now, in a certain seashore, the height of a retaining wall with a smooth vertical backfill. What is the height of retaining wall? 4.4 meters. 4.4 meters. The foundation is over an expansive collapsible soil having a horizontal surface. What is the meaning of horizontal surface? So back of wall, if this is a wall and this is going to be a horizontal surface, so this is 4.4 meters. And at the level of top of the wall carries a UDL of 197. What is the meaning of at the level of the wall? It is going to be carries a UDL, which means that is a surcharge. So what is the surcharge? 197 kilopascals. Okay. The unit weight gamma 19 and phi value 30 degrees. What is the nearest magnitude of total active pressure? Means here force nana per meter length. You see the units. Actually, you see the units. What is the units over here? Kilonewton per meter, which means that is a force. So now, as it is a surcharge, you know, at the top, there is an active, right? You know, at the top, Ka into Q. Yes. And at the bottom, Ka into Q plus gamma into H. So you please find out the total force over here. First, you please find out what is Ka value 1/3. So now I want to find out the nearest magnitude of total active pressure per meter length. Per meter length means if you see the units, that is going to be force. For pressure, kilonewton per meter square. For force, kilonewton per meter length of the wall. So now you see what is this value? 1/3 into 197. 1/3 into 197. You please look. So it is going to be 3618, and which is going to be 6, and then 17. 17 means 5.67. 65.67. 197. I'm not using any calculator over here. 197 by 3. So 3618 and 17. 3 5s. So 15.20. 36 again 18, 20. So recurring 65.66666. So I took 65.67. Now what I do over here is, as I know, this is going to be Ka into Q plus Ka into gamma H. Already Ka into Q is going to be 65.67 plus Ka into gamma H. 1/3 into 19 into 4.4. So it's quite hectic. Yes, so you need to solve this one. What is the nearest value? And if you use find out this value now, this is going to be again 36.33. So 6.33 into 4.4. You please solve this one. Please solve this one. Solve these values. 6.33 into 4.44. I don't want to waste my time over here. So that's the reason why I will be using calculator. 6.33 into 4.4 plus 65.67, which is going to be 93.522 kilopascal, means kilonewton per meter square. Then what is the active force over here? The active force is equals to 4.4 by 2 into 65.67 plus 93.522. So the answer is going to be 350.224. The nearest is going to be 360. They're asking the nearest magnitude. Answer is going to be 360 kilonewton per meter. 360 kilonewton per meter. See, actually what is happening is in the IES recently what they're doing is, I don't know how the paper setter is going to be doing, but in the case of ESC, the calculations should be in such a way, it should be easy calculations. But in the past few years, from the past 2 to 3 years, they are giving the calculations which is equivalent to gate level. So my dear students, the tip is you try to solve. See, in the classroom, I don't have much time. I will not be having much time to discuss some more. I can more focus on the concepts, but while you are preparing, you have to more focus on the, without using calculator also. Try to go with the nearest values. In the case of gate, you have a calculator, but in ESC, you always try to go with without calculator. Try to solve this one without a calculator. So initially it may take time, but if you do solve more questions, then you will be habituated with that. So that's about this question. Now, so these are the ESC questions, and this is one of the gate question I have been discussed. And let's see this question. A smooth rigid retaining wall moves as shown in the figure. The backfill material is homogeneous and obeys the Moore Coulomb pendulum book. The major principal stress is, now you see, look my dear, this is initial position and this is the final position, which means the wall is moving towards the backfill or not? Towards backfill. When the wall is moving toward backfill, is it the passive state or active state? Passive state. Now, in the case of the passive state, you know that when the wall is moving towards the backfill, passive state, in the case of the passive state, you know, the vertical stress is going to be minor and the lateral stress is going to be, vertical stress is minor and lateral stress is going to be major. So what they're asking is the major principal stress is. So what is the major principal stress, sir? Parallel to wall face and acting downward. What is the meaning of parallel to wall face? This is a parallel to wall face and acting downward. Is it? No. Normal to wall face. What is the mean by normal? This is a wall and this is a normal. Yes. Oblique to the wall. Oblique means having some angle. No. Oblique to the wall facing. No. So this is normal to the wall face. See, just simply that twisting the terminologies. You know that when wall moves towards the backfill, then the lateral earth pressure is the major principal stress. Yes. And what is the action of this one? This is going to be normal to the wall or parallel to the wall? Normal to the wall. That's it. So the answer is going to be normal to the wall face. This is the GATE 2012 question. Okay, so now you see a 3-meter height retaining wall is supporting a 3-meter height retaining wall is supporting a saturated sand. So now this is a 3-meter height retaining wall. Three meters. Is supporting a saturated sand due to capillarity. Now there comes the capillarity effect. So initially capillarity gamma sat is how much? 18. See, the bulk density means saturated. So whatever the value is going to be here, gamma in full saturation gamma becomes gamma sat. In dry state gamma is going to be gamma. And angle of shearing resistance means a phi. Angle of frictional resistance or shearing resistance both are same, phi. Now the change in the magnitude at the base due to rise in the groundwater table from the base of footing to the ground surface. Now from the base of footing to the ground surface, this is here from the base of footing. So what is this? Now this is going to be gamma sat only still, which is going to be 18 kilonewton per meter cube. And phi is equals to 30 degrees. This is the groundwater table and this is going to be capillarity. This is case A and this is case B. My dear students, listen to the point clearly. First of all, let me find case A. What is sigma V, sir? What is sigma V? They are asking what is the magnitude of earth pressure at the base. At base, what is the vertical stress here? Gamma sat into H. Here also vertical stress gamma sat into H. Now, my dear students, first one, this is due to whom? Capillarity. And this is due to groundwater table. Remember, does capillarity has a hydrostatic pressure? No. See, in the case of here, you know that no water table, no hydrostatic pressure. no water table, even though it is going to be capillarity or rainwater, I don't care. I told you clearly, capillarity is due to surface tension. It is not a hydrostatic pressure. That is a capillary pressure. Capillary pressure is different and hydrostatic pressure is different. Hydrostatic pressure means positive pore water pressure. I'm telling you again, hydrostatic pressure means a positive pore water pressure. Whereas the capillarity means negative pore water pressure. If you have any doubts, you please go through the chapter number 7, you can find it out. So now as there is no hydrostatic pressure, then I can apply the active pressure for all Ka into gamma sat into H. Because there is no hydrostatic pressure, right? Thus this saturation is due to capillarity. The saturation is due to capillarity. So here, as there is a water table, hydrostatic pressure. So sigma V is gamma dash into H plus gamma W into H. Then what is PA over here? This is PA1, PA2, Ka into gamma dash into H plus gamma W into H. See, I am telling you here, due to capillarity, above the water table. See, I am asking at this point or not. You observe, please. At this point, you please look over. Water table is here. So at the base, sorry, that's not water table. Yet water table, hydrostatic pressure is equals to 0, because this is the water table. I am asking you at the base. At the base, what is the pore water pressure? Means at the water table, the water table is going to be here. Now, the change in magnitude due to rise in groundwater table from the base of footing. This is from here to here if it rises. And initially, water table is at base. At the water table, pore water pressure is going to be 0. When pore water pressure is 0, then you can apply the total vertical stress. Yes, but here, due to water table in this zone, then pore water pressure is going to be there. What is the pore water pressure? Gamma W into H. So the water table has been raised from here to here. This is initial and this is the final. So now what is PA1? 1 by 3 into 18 into 3, which is going to be 18. And what is PA2? 1 by 3 into, so take the gamma W as a 10, which means 18 minus 10 into 3 plus 10 into 3, which is going to be 38 kilopascal. So now the change in the lateral pressure is 38 minus 18, which is going to be 20 kilopascals. So answer, what is initial? 18. See, I'm just using my basics. What is the basics? At the base, there is a water table. At a water table, no hydrostatic pressure. And now, due to water table, there is a hydrostatic pressure. What is the hydrostatic pressure? Gamma W into H. That's it. So now, I hope you understood this. What is the increase in lateral earth pressure? 20 kilopascals. Now, let's see the next one. This is the last question that I am going to discuss in this chapter. A homogeneous, see, I am picking the questions which are going to be ambiguous. I am leaving the previous ESE and GATE questions for you to solve normal questions, means that you can solve on your own. And I am picking some questions which are going to be ambiguous, which can be, means which requires an explanation. That is the reason why I am taking time for these questions. So now you see a homogeneous gravity retaining wall supporting a cohesionless backfill. This is a cohesionless backfill. the lateral active earth pressure at the bottom of wall is going to be 40. This is a wall and this is the cohesionless backfill, and they clearly mentioned that the lateral earth pressure at the bottom of the wall. At the bottom of the wall, the lateral earth pressure is going to be how much? 40 kilopascals. Okay. And what is the height of wall? 6 meters. And what is the base of wall? 4 meters. Okay. Now, the minimum weight of the wall, there must be some weight of the wall, W, required to prevent from overturning. Now, see, this is a design condition. Actually, these things you are going to discuss in the case of the RCC and in the case of the irrigation. But now I am going to tell you, because this is not going to take much time. What is mean by overturning? Now, you see, I am here. This is a wall. This is the lateral earth pressure. Yes or no? This is the lateral earth pressure. This lateral earth pressure will exert some force. And if the wall is going to be moved, it is going to be overturned or not, which means the wall may overturn like this with respect to the heel or with respect to the toe. So this is going to be toe and this is going to be the heel portion. This is the toe portion. Sorry. You take anything over here. So let's take a point A. About A, for no overturning, whatever the force over here, active force, it is going to be act at a height of h by 3. And now this is a weight which is going to be act at a distance of 2 meters, because centroid, right? As it is a rectangle, the weight exactly acts at the centroid. So that the distance is going to be 2 meters. So what is the resisting moment over here? What is the resisting moment? Resisting moment is equals to the weight into 2. Resisting force is going to be resisting force into lever arm, means weight into 2 meters. And what is the causing moment over here? You please observe which is going to be causing the moment over here, which is going to be causing the force. So active force Fa into h by 3. For no overturning, or the maximum, the overturning, they're asking what is the minimum weight of wall. The minimum weight of wall required is going to be like W into 2 is equals to Fa into h by 3. What is Fa, sir, here? What is Fa, please? Half into base, 40 into height, 6 meters. Half into base into height. What is the height over here? 6 meters. So now 20 into 6, then it is going to be 1 by 2 into 40 into 6, 20 into 6, which is going to be 120 kilonewton per meter. So now what is the weight over here, please? So the weight is going to be weight into 2 is equals to 120 into what is h? 6 by 3. The weight is going to be 120 because 3 2s, 2 will get cancelled. 120 kilonewton per meter. They are asking expressed in terms of kilonewton per meter. So the answer is going to be A. Answer is A. See, just there is an application. It's not something that rocket science or something. So here we're just looking over what is overturning. What is overturning? So you know that if you remember, the gravity dam or retaining walls are failed by overturning, sliding, shearing. All this stability analysis in reinforced concrete structures RCC. There is a chapter known as retaining walls. there you are going to see the stability analysis of the retaining walls. But as I know, means as we know, who is the resisting over here? Weight. We're an engineer, right? When we design, there must be resisting, there must be causing. Who is resisting? Weight of the wall. Who is causing? Active force. So what is the causing moment? Active force into H by 3 about A. What is the resisting moment? Weight into 2. What is the causing moment? Fa into H by 3. So that's about this, and I'm giving you this as a homework for you. I'm giving this as homework for you. I have been discussed these questions. This is a profile. So there is nothing over there. So they have given these details. The soil profile at a site consists of 5 meters thick sand. So you please go through this question, try it. Understand the question carefully. The total active force they're asking, active earth pressure expressed in kilonewton per meter square. Expressed in kilonewton per meter square, which means what is the total at this point A, right? They're asking the at the point A, what is the active earth pressure at A. So you write down the equation, you can find out the values. So that they are not asking force, they are asking the active pressure at a point A. You please find it out. I hope you can solve this. So I gave you each and every detail required for solving. That's all about this chapter. So we have discussed and we have covered elaborately various conditions of the retaining walls, and we covered for various ESC questions and gate questions also. So as a 1 mark questions, 2 marks questions, and all those things are there. So with this, we conclude this chapter, and after the break, we are going to start new chapter, stability of slopes. Have a break. Now it's 11:15. Let's have a break up to 11:35, 20 minutes. And after that, we'll start a new chapter. So 20 minutes break. Have a break and we'll see after the break. Now, let's come to the, see, you try it on your home, you can find it the values. So we have covered almost all the topics in the Rankine's theories. So you please go through the notes once again. Now, we're going to start a new chapter. We're going to start a new chapter. Yeah, Mr. Brijesh, you have sent me one question. Yes, Mr. Brijesh, you have done good, but the procedure that you have taken is a long procedure, because in ESC, you don't get that much time, right? So you have taken the K into Q and you have added everything, and at the end you remove that, but it will take more steps, right? So instead of more steps, you can find out that time for solving. So that's one procedure, but if you feel you are going to get less time, that's fine, Brijesh. So now let's start a new chapter. So now we are going to discuss about chapter number 15, stability of slopes. Stability of slopes. See, chapter number 15 now, stability of slopes. Now, let's come to what is the purpose of stability of slope. You see, listen to me first, the general discussion. You observe, when you are going to provide a slope, see, the slopes that we are going to provide is for railways, for earth dams, for embankments, for highways, for for any field and for canal cuts also. You see, for example, if this is a road, for highway, this is going to be the embankment, highway, and this is going to be the embankment, and in the case of the canal, you see this is a ground level and this is a canal. So whatever is nothing but canal cut is also going to have a slope. And you see this is an earth dam, this is a earth dam, and again it is going to have a slope. So you take whatever the structures are regarding to the civil engineering, and whether it is going to be highway embankment or railway embankment or canal cuts or earth dams or whatever the structures that you are going to take with respect to the soil mass, everything has a slope. So this is canal cut slope and this is embankment that is going to be having some slope, yes or no? So as we are going to provide a slope, now the question for us, see, in the previous chapter number 14 also, I started the same way. I started there, Baba, wherever you there, you are going to provide a slope. And now, if you observe the figures that I am going to show, see, this is an earth dam. This is a dam. So this is a dam slope, right? Whatever, this is nothing but a dam slope. You can observe there is nothing but a dam slope. So, and this is a downstream and there is an upstream side. So this is a dam. And you can see this is a railway. And this is railway embankment, right? And this is nothing but the slope, embankment slope. So whatever we see, this is nothing but embankment. It has some slope. So in reality, wherever you see, whether it's earth dam or embankment or canal cut or railway bridges, anywhere, wherever you're going to fill a soil mass, you provide a slope. Now the question is, as an engineer, we have to provide the slope economical and at the same time safe. You see, you observe whatever this I am writing, this is nothing but a flat slope. This is a flat slope. Flat slope is going to be very safe. Flat slope is going to be very, very safe. Or I can write. Whatever, this is nothing but a flat slope. So flat slope means safe. See, when the slope is going to be flatter, then it is going to be safe, but uneconomical. So if you go for the flat slope, it is going to be safe, but uneconomical. Why, sir? Sir, just imagine, sir, if I provide more flat slope, then you can see, if you observe, if I provide more flat slope, then you are going to fill more soil or not? Yes or no? So this is going to be the flat slope. When I provide a more flat slope, then what happens over here is the base width of the slope is going to be more. So the base width of the embankment is going to be increases or not? When the base width is going to be increases, you have to provide a more soil mass. So the flat slope is safe, but uneconomical. But now if I go for a steep slope, now you see, this is a steep slope. Steep slope is economical, but not safe. Sir, why they are not going to be safe, sir? Sir, if you don't provide a sufficient slope, then the soil will slide, sir. Okay. So if the soil is going to be slide, sir, then for a steep slope, soil will slide, but economical. Why economical, sir? If you provide a flat slope, this is a flat slope, then the base width of the embankment is going to be more. And if I provide a steep slope, this is going to be a steep slope, right? So if I provide a steep slope, then the base width is going to be less economical, but it is not going to be safe. I told you clearly in the previous chapter, safe slope, unsafe slope. Now, as an engineer, we have to design as an engineer, one should design a slope which is steep and safe. Because if I go for a steep slope, it is going to be economical. And at the same time, I want to be safe. So now I am going to draw one more slope over here. So whatever this slope, this should be steep and economical. So this is the design slope. Mind it. So in the case of the stability of slopes, first of all, I'm giving you various aspects where you're going to provide the slopes. And if I provide a flat slope, I'm saying economical, uneconomical. If I provide a steep slope, economical but not safe. But as an engineer, you have to provide the design slope as a steep and it should be economical. Sir, okay, sir. Then what is the meaning of the stability of slope, sir? Sir, stability means strength check, whether it is safe or not. So you know that loss of or fail of slope causes loss of the property and life. Failure of slope causes loss of property and life. So civil engineer must check, or you don't need to write all these things. So as of we, now let's see us. We need to, as a civil engineers, what we need to do is whatever the proposed slope, whether it is an embankment or canal cut or a dam slope or flat slope or steep slope, you must have to check the safety by means of its a factor of safety. By means of its factor of safety. Now I'm going to show you some failures. See, as I show you, this is the dam slope and this is embankment slope. Now if you look, this is the, I hope you can observe this failure. What is this? See, this is a highway embankment. Whatever this is nothing but embankment. This is an embankment. And if you observe here, what is happening is whatever the soil mass is moving outward and downward. Yes or no? The soil mass is moving outward and downward in a rotation, right? Yes or no? So this is nothing but a slope of failure. Whatever it has some slope, see, this is going to be having some slope here. If you observe, this is having some slope. And if you see, if the slope is not going to be safe, then what happens is that the soil mass will slide. The soil mass will slide, and this is going to be slope failure. This is going to be a slope failure. So I hope you understood. There is an embankment and road embankment or highway embankment. In the case of the road embankment, what I'm showing you over here is, if you don't check the stability, then there is a possibility the road is going to be fail in this fashion. When the road fails in this fashion, then definitely such a type of failure is known as a slope failure. Now, my dear students, as an engineer, what we need to do is we need to check the safety. We need to check the safety. Safety means a factor of safety. So why this has happened, sir? Then we'll see. We see why it is going to be happen. Why do we provide slopes, sir? So because soil mass cannot stand vertical, sir. That's the reason why we can provide a slope. You know, the unsupported depth of excavation. See, you can provide only vertical height for clays. There is a vertical slope, right? Vertical slope for clays only up to critical height, HC. But in sands, I told this point earlier also, in sands, slope cannot be vertical. If you want, you please go through the previous chapter. In chapter number 14, I explained you while I was discussing the unsupported depth of excavation. I told you for cohesionless soils, C is going to be 0. When C is going to be 0, critical height is going to be 0, which means in the case of sands, you cannot provide a vertical. In the case of sands, you have to provide the slope with some inclination. With some inclination. So this is inclined slope and this is the vertical slope. Mostly we use C5 soils only. Okay. Now you see one more failure. You see, this is a mountainous slope, right? This is a mountain slope. And I hope you know, this is nothing but a landslide. You can see these type of landslides. I have shown you one figure in the previous chapter also. You see how the movement of the soil is going to be there. Downward and outside. So when the soil moves downward and outside, you see this is known as a landslide. So you can observe these landslides in the case of the mountainous slopes. In the case of the mountainous slopes, you observe a small, means a huge amount of the soil mass will slide along the length. Yes or no? A huge amount of the soil mass is going to be soil slides downward and outward. See, first it moves downward and it is going to be moving away from the slope or not. So when a slope is going to be moves, or when a soil in a slope moves downward and outward direction, then you are going to say it as a slope failure. Then you are going to say it as a slope failure. So these are different type of the slopes failures. I'm showing you. This is a failure and this is also going to be the failure. Now, as an engineer, what we need to do is we have to check whether the given slope is going to be safe or not. That is meaning of the stability of slopes. Checking safety of slopes. So I hope you understood what are the different causes. And now let's see. So what we are going to learn in this chapter, sir. First of all, as somebody asks, sir, why this soil has been failed? What are the reasons behind soil failure? And number two, what are the different type of slopes? See, this is a man-made slope. Yes, this is a man-made slope and this is a natural slope. What are the different type of failures and how you are going to find out the factor of safety? Means factor of safety means you can say if the factor of safety is going to be more than 1, that is going to be safe, and less than 1, that is going to be unsafe, and equals to 1, critical. So my dear students, what we are going to learn in this chapter is finding the factor of safety. In simple words, you are going to determine the factor of safety. And if that factor of safety is more than 1, we say it's safe. If it is less than 1, we say it unsafe. So now let's come to the topics over here. So factor of safety represent with FOS or F also. FOS or F. So factor of safety represent with F. Meaning of F is always factor of safety means resisting by causing. See, I am not completing the sentences. Sir, is it a force? It can be. Sir, is it a stress? It can be. Sir, is it a moment? It can be. So, you take a force or stress or a moment. Any body. See, the best example I will be taking before the break, I have explained one condition of the retaining wall, overturning condition. I hope you remember there. I hope you remember there. So there, what is a resisting moment? Due to weight. And what is the causing moment? Due to earth pressure. So for any body, there must be a stabilizing force, which is known as resisting, and a destabilizing force, which is known as causing. It may be a force, it may be a stress, and it may be a moment. And you know that whenever the factor of safety is going to be greater than 1, slope is safe. And factor of safety is less than 1, unsafe, and factor of safety is equals to 1, critical. So what is meant by slope failure, sir? Slope failure means if a soil mass moves or slides downward and outward movement or outward direction from rest of the soil, then you are going to call it as a slope failure. If a soil mass moves or slides downward and outward direction, you see I have shown you downward and outward direction, downward and outward direction, then you are going to means from the rest of the soil mass, then we are going to call it as a slope failure. Sir, what are the reasons that causes the slope failure, sir? Now, factors that influence the slopes to fail. What are the factors? Think and say, see, This is a slope, it has been failed. This is a slope, it has been failed. And this slope might fail. And this slope might fail. And what are the factors that the slope is going to be fail? Slopes fails due to number one, it's a self weight of the soil. What is meant by self weight of the soil? You see, listen everybody. If I provide a steep slope, the weight of the soil is going to be more. The self weight would be there, which means weight, gravitational force. So what is meant by W? Gravitational force. In the case of the steep slope, the weight of the soil is going to be more, which makes the slope is going to be vulnerable to the failure. So number one is it's a gravitational force. It's gravitational force. And number two, sir, there is no inward, sir. The meaning of outward means some amount of the soil will be sliding away, right? What is the meaning of soil? Soil will slide away. Away means, so from the rest of the soil mass, it will move outward direction, right? You see the meaning of outside direction, outside. Soil slides downward and outside direction. So number one, gravitational force. Number two, seepage force. Seepage means during rainy season. Array, I hope the people who are living in the northeast side, they know it very well. They know it very well. You see, landslides are going to be occur, right? When does the landslides occur? During summer season or during rainy season? See, landslides are going to be occur during the rainy season. Yes. Why, sir? Sir, when rainwater comes, sir, that rainwater seeps into the soil mass, sir. And due to the rainwater seepage, see, I'm drawing that slope once again over here. Now, let's say number one, gravity. See, you observe the weight is going to be there or not. So number one, the gravity in this slope zone, whatever the gravity, which means weight. See, in the slope, if the slope is going to be steep, then definitely, if the slope is going to be steep, then the weight of the soil is going to be more. If the slope is going to be steep, weight is going to be more, then obviously there is a failure. And seepage, if rain occurs due to seeping of rainwater, which is nothing but seepage. So due to seepage and due to seepage. Next, third one, due to earthquakes. Earthquake is also going to be, see, we know due to earthquake, so due to earthquake, we know that, so liquefaction condition. Some student, Arey, sir, you are not don't discriminate all Indians, sir. Okay, my dear, I did not discriminate anyone. See, I said you, the mountainous regions are there in the northeastern states. So there, those people might see the landslides continuously. That's why I said, in Andhra Pradesh or in Karnataka or in Maharashtra, we don't see much of landslides. So I'm not discriminating anyone. So now, due to seepage also the slope can fail. And earthquakes So due to earthquake, liquefaction. What is the meaning of liquefaction? Loss of shear strength. When the strength is going to be less, then definitely the slope is going to be fail. And apart from that, if there is any surcharge load or construction loads. See, due to the construction loads, this is a construction load also, and this construction load also might cause a failure, and erosion. And erosion also. See, I'm not going to show that, but I can show you over here. Whatever this is nothing but erosion. So due to erosion of the some portion of the soil also, then you can see erosion also causes. So these are the some of the reasons that causes the slope fail. So weight means gravity, sea pace, earthquakes, construction loads, and erosion. So these are the different factors on which the slope is going to be depends on. Now, sir, you said slope failure and you have showed us a different type of slopes over here. Now, what are the different type of slopes and how you are going to define the type of failures? See, before going to that different type of failures and slope stability analysis, we need to know what are the type of slopes. So now let's come to the type of slopes. Types of slopes. So in the case of the types of slopes, we generally define the slopes as two types. One is infinite slopes, other one is finite slopes. One is going to be infinite slopes, other one is finite slopes. So while we are going to define the safety, we define the slope into two types. One is infinite, the other one is finite. The meaning of infinite is not extreme large, means so it's not symbolically you say it's not going to be infinite. If the length of a slope is going to be more, then we said as infinite slopes. If the length of slope is more, then we said as a infinite. And if the length of a slope is going to be less, so whatever the slope you have, if the length is going to be more, we can call it as infinite slopes. And if the length is going to be less, we can call it as a finite slopes. And sir, what are the examples of infinite slopes, sir? Now you see, sir, what is this, sir? Mountainous slopes, sir. See the length of the slope. This is a slope, right? And the length of slope is going to be literally very, very large. This is a slope. So the length of the slope is going to be very, very large. Yes, such type of slopes are known as infinite slopes. So this is an example for the infinite slope. So what is an infinite slope? If the length of the slope is going to be more, we call it as an infinite slope. And example is going to be mountainous slopes. We can call it as natural slopes. Example, mountain or hill slopes. Sir, what about the finite slopes, sir? You see, whatever this is nothing but the finite slope or not? Whatever the slope you see, this is going to be a finite slope. Because you see, you observe over here, this length is going to be finite. So this length is going to be finite. I can, because we are constructing it, while you are constructing without knowing the length, are you going to construct the slope? No. So if the slope is going to be natural, we call it as infinite slope. And if the slope is going to be man-made slope, then we call it as a finite slope. So examples are embankment, earth dam, canals, etc. There are a lot of man-made slopes. So you see, there are different type of slopes. One is an infinite slope and other one is going to be finite slopes. So as there are different type of slopes, the type of failure is also going to be C. So my dear anonymous attendee, I hope you are very good in geology, but I am very poor in social and geology. I don't know much hills and all. So I'm sorry. And some of the student who is shown your educational knowledge regarding to the geology in Maharashtra, in East, in South, there are mountains region all over India. Yes, everybody knows that, but I say mostly in the Northeast so that the people can easily think over that. Okay, focus on the actual points, not on these points. I hope if you are focusing on the same type of concepts, I'm the first person who is very happy. That's not geology, that's geography. Okay, fine. If you want to teach me some biology also, you can teach also. But I am not good in all those subjects. I am good in whatever I teach. Sir, any length criteria here? No, just simply what we can do is, if it is going to be natural slope, that's the reason why I'm just classifying broadly as, if it is a natural slope, you can just take it as infinite slope. And if it is a man-made slope, you can just take it as a finite slopes. Now, let's see. Yes. So it's also depends upon the, yes, it's also depends upon the type of soil. That's the reason why I said it's gravity. Gravity means it's not only depends upon, means it depends upon the type of soil mass. So now let's come to the analysis. See, as we know the type of slopes, now listen, as we know the type of slopes, now I am going to discuss about the type of failures. So types of failures. Now, how the type of failure is going to be happen, sir? Number one, translational failure. Translational failure. Sir, what is the meaning of this translation failure? Let's say first. See, listen, this is very, very important. If you understand this only, then you can understand later. So, instead of asking a silly doubt, so please focus on the actual concept now. See, this is a translation failure. Translation failure occurs in the case of the infinite slopes. Infinite slopes. So, what is the meaning of the translation failure, sir? If slope fails along the length and parallel, comma, planar to slope surface. Look, if the slope fails along the length and parallel, comma, planar to the slope surface, then we are going to call it as, a translational failure. So what is the meaning of this translation failure? Now let me take this slope. You see, this is a slope, right? Infinite slope. Now let's draw that slope once. This is a slope surface. This is a slope surface. And the slope surface is making an angle I, where I is a slope angle, means angle of the slope. Now, what happens over here in the case of the translation failure is, If you observe, in the case of translation failure, soil will fail. Soil will fail. Now, see, you observe the soil mass will fail as a slope fails along the length and parallel and planar to the planar means linear. Curvilinear means curve. Planar means linear and parallel to the slip surface. So parallel to the slope surface. Now you see, this is a failure or slip surface. So now you observe, whatever the soil mass over here, this soil mass will move downward and they are going to be finally moves outward of the slope. So that's how it is going to be happen. You please observe, this is a slope and beneath the slope what happens is the failure slip surface first moves inside so that the weak soil mass will comes outside and this soil mass moves. If a soil slope or if a soil slides or slope fails along the length and parallel comma planar to the slip surface, such a failure is known as translational failure. Translational failure. So this is known as a translation failure. And now you know that. Let's see. Let's go back to our chapter number 14. If there is any failure plane and on that failure plane, definitely there is a normal stress and definitely there is a shear stress and definitely there is a shear strength. Yes or no? So, you know, this is nothing but a critical plane or any plane. On any plane, you can find out the normal stress, shear stress and shear strength. Now, I have to check whether the slope is going to be safe or not. Now, you see, this is a normal stress. Here, this is a shear stress. And whatever, this is nothing but the shear strength. So, can you please tell me what is the factor of safety over here, please? What is the factor of safety over here? Please tell me. What is the factor of safety? Now, just now I told you, what is the meaning of factor of safety? Resisting by causing. So, when does the soil is going to be fails or slope is going to be fail? When the shear stress is more than the shear strength. As long as the resisting, who is resisting over here? Shear strength. By who is causing over here? Shear stress. So yes, by tau. So now in this case, in the case of the translation failure, you can find out the factor of safety. As the slope is going to be slides, along the failure or slip surface, there is a shear stress, and in order to resist that, there is a shear strength. Whenever both are same, then we are going to call it as a verge of failure or critical condition. When shear strength and shear stress both are same, what is the factor of safety? 1. When both are same, factor of safety is 1. Can I say it is a critical condition? And as long as the shear stress is less than the strength more, stress less. So factor of safety more than 1, safe. If this shear stress is more than the shear strength, then the soil will fly. So this is a slope, soil will slide along the length of slope, and such type of failure is known as translational failure. Now, I hope you understood. Second one, rotational failure. Here, soil fails by rotation along the slip surface. Soil fails by rotation along the slip surface. Now, the perfect example here you see, if you observe, this is nothing but a rotation or not? if you observe, this is nothing but a rotation. Yes. So in the case of the finite slopes, you can observe this is a rotational failure. This is a rotational failure and is the best example for the finite slopes. So this is going to be the rotational failure. In this, soil fails by rotation along the slip surface. See, sir, what is the meaning of slip surface? Failure, Nana, failure surface. Okay, failure surface. And in this case, the soil is going to be slides along the length or not. As the soil is going to be slide along the length, then it is going to be translation failure. So this type of rotation failures can be seen in case of finite slopes. It can be seen in the case of finite slopes. Now, let's take this is a finite slope. This is a finite slope. So now this is a hard strata over here. Hard strata. And this is a slope. And slope surface. See, I'm just showing you the same one. So there is an embankment. I'm taking you this slope. Observe. I hope I took the same thing. Observe. Whatever, this is nothing but the slope. So now, in this case, this is going to be the rotation, right? The soil is going to be fails along the rotation, means along the slip surface by rotation. So now the soil starts to fail. Mind it, the failure can start anywhere over here. It can be here or here or here or here. You cannot say directly, sir, will the failure starts at this point, sir, or this point, sir, or this point. Failure can start anywhere. If you see, here the failure started at this point, here the failure started at this point, here the failure started at this point, and if you see here, this is the failure, right? So the failure can start at any point. So now, if the failure starts here, let's say, the failure may end somewhere over here. The failure may end somewhere over here. Or the failure may passes through the toe. The failure may passes through the toe. Or the failure may passes through below the toe, and then it is going to be touches the base. This is the base, and this is face or slope. See, if you observe, my dear students, in the case of the rotation may start at any point and may end at any point. So if it is going to be stopped at this point, then you are going to call it as a face or slope failure. Then if I call it as a toe, then we call it as a toe failure. If it passes through below the toe, then we are going to call it as a base failure. So now, my dear students, how many rotation failures are there? 3. What are those? Face or slope failure, base or toe failure, base failure, and toe failure. Sir, what is the meaning of this face failure, toe failure, and base failure, sir? When I am going to see this, all these things, sir. Now let's see. First one, face or slope failure. If soil above the toe is weaker than below toe. If soil above the toe is weaker than the below the toe, because failure occurs in weakest soil. So when the soil is going to be If the soil above the toe, if the soil above the toe is going to be loose soil mass, or if it's going to be weak soil mass, then you are going to see the phase failure. And next one, base failure. So in the case of the base failure, if soil below the toe is softer or weaker than above toe, then we call it as a base failure. Simple, Nana. If the soil below the toe is going to be weak, then the failure is going to be base failure. If the soil above the toe is going to be weak, then it is going to be phase failure. Sir, then what about the toe failure, sir? Toe failure. The toe failure means if soil above and below toe has relatively same strength, then we are going to call it as a toe failure. So means above the soil weak, phase failure, below the soil weak, base failure. And if it is going to be both are similar or relatively same strength, then the type of failure is going to be toe failure. And mind it, it is the most common seen failure. This is the most common seen failure. Now you go over here. If you look over here, the failure is happening to the through the toe. Yes or no? This entire soil mass has been moved through that toe, which means whatever the soil mass will slide and the failure surface is going to be passing through the toe. If the slip surface passes through the toe, failure. If a slip surface passes through phase failure, and base failure. Sir, how to find out the soil is weak, sir? It depends upon the denseness, Nana. You know the relative density concept, right? Medium dense or low dense or something like that. See, I did not discuss the factor of safety yet. So then the toe failure. When the toe failure occurs, sir, when the slope, whatever the slope is there or not, the slope angle, I is nothing but the slope angle. So where I is slope angle, when the slope angle is going to be more than 53 degrees, there is a possibility always the failure is going to be toe failure. As I told you, we don't provide a flat slope. We don't provide a steep slope. We provide a steep and economical slope, and mostly that steepness is going to be more than 53 degrees. So then that toe failure is going to be seen. Most common seen failure. So you can see the entire soil mass is going to be rotated like this. Okay. Now, see, sir, you have said this one. Yes. You have said this one. Now, let's see this toe failure. If soil above and below toe has relatively same strength. Now, there is one more thing that defines the type of failure. So that failure is going to be by means of the depth factor. To distinguish type of rotational failure. Then you can see there is one factor known as depth factor. DF is equals to, let's say if there is a soft soil, let's take let's say the height of the slope as h, and depth of the soft soil as a D. So if H is height of slope and D is, or I can write there itself. If H is height of slope and D is depth of soft soil. Height of slope and D is a depth of soft soil. Then that depth factor is given as, depth factor is equals to H plus D by H. H plus D by H. See, this is a depth factor, and based upon this depth factor, you can distinguish the slope. Now, you see, in the case of first, base failure. For base failure, now you please observe what is the meaning of a base failure. When does the base failure is going to be happen? If a soil below the toe is softer or weaker than above toe. Now you see, in the case of D, what is the D? Depth of the soft soil, which means in the case of the base failure, depth of the soft soil below the base, there is a soft soil. And if there is a soft soil, then D is going to be greater than 0. When D greater than 0, please come on, have a look over here. If D is going to be greater than 0, then H plus more 0 by H, then definitely the DF value is going to be greater than 1. And now, in the case of the toe failure, no soft soil, then D is equals to 0. So if D is equals to 0, then what is the DF value? DF is going to be less than 1. For the base failure, DF is going to be greater than 1. For the toe failure, DF is going to be less than 1. And the last one is phase failure. Mind it, my dear students, think about once. Look, this DF is going to be H plus D by H. Yes. And I can write H by H plus D by H. Then I can write this one 1 plus D by H, which means always depth factor is more than 1 or equals to 1. Yes or no? Because if I rewrite this, I can write this one as 1 plus H by D also. I can write this one as 1 plus H by D. So always 1 plus D by H is converted as 1 plus D by H. If D0, 1. If D greater than 0, 1, greater than 1, which means depth factor cannot be less than 1. But you see, if you observe over here, for base failure, I said that D is going to be greater than, DF is going to be greater than 1. And for toe failure, DF is going to be, so not less than 1, sorry, this is not less than 1. DF is equals to 1. And now, by interpolation, or by extrapolation, not interpolation, by extrapolation, we assume DF is going to be less than 1. See, generally it is not going to be possible. Generally, it is not going to be possible. So we don't see much of the phase failure. We see mostly toe failure or base failure. So these are the type of slopes failures. Extrapolation means our assumption. Extrapolation means by assuming. So for analysis now, you please observe, as we have a, see that's what I am saying, sir, can DFU. I did not say the soil. There is no soil. I said no soft soil is there. That is a soft soil, not a normal soil. I told you there is no soft soil, right? So now you come over here. If this is a slope, I told you there are various type of failures. Yes, but I said you generally the failure, most commonly seen failure is going to be whom? Toe failure. So for the analysis, we assume the failure is going to be a toe failure. So slip surface is assumed as circular arc passing through toe. Slip surface is going to be assumed as circular arc passing through toe. Why, sir? Sir, we assumed it is going to be, sir, we know it is a rotation, sir, and now I am going to take that rotation. Sir, that rotation may be ellipse or circle, but when I do analysis, I have some assumptions. And by taking the leverage of the assumption, I am saying you slip surface is assumed as a circular arc passing through the toe. Passing through the toe. So now, so this is the slip surface passing through the toe. Yes. So now you see. For the analysis, we are going to assume this one as passing through the toe. Now, this is going to be a circular arc, and definitely it must be having some center arc. Let's take the center as O. And if I take it as center O, if I take this point as center O, then from the center, as it is a circular arc, then definitely whatever this is nothing but an arc having radius r. No. So that's it. So in the case of the analysis, what we do is for the analysis, as we know, it is a rotation failure and it passes through the toe, and the slip surface is assumed as a circular arc passing through the toe, and now it is going to be making an angle of theta. So now you see, sir, as it is going to be rotation, see the rotation means then definitely there is a moment, and now this moment is going to be driving moment or causing moment. Driving moment or causing moment. And you see, if the failure is going to be happen in this manner, please go through this figure once again. If the failure is going to be happen in this manner, then definitely there must be some resistance opposite or not. There must be some resistance. This is the resistance. This is the resistance offered along the slip surface, and this is the rotation. Rotation, and this is going to be the resistance. Now, along the slip surface, there is a resisting moment. So represented with MR. Now, how to find out the factor of safety, sir? Sir, come on, sir. Please tell me the factor of safety. What is the factor of safety now? Resisting moment by causing or driving moment. Sir, how to find out this? We'll see this later. MR by MD. See how to find out the factor of safety, we'll see later. I'm just giving you the type of failures, and the stability analysis we'll be seeing later. So this is going to be the slip surface. So that's about the rotation failure. So how to determine this factor of safety, we'll be seeing later. What is the resisting moment? How we are going to find out. And what is the driving moment? How we are going to find out. We'll see it later. So this is the radius R, where R is radius of arc. So now, next one. Third one, compound failure. So in the case of the compound failure, if a hard strata is located at near depth below 2, which means if a hard strata is going to be located near a 2, so then we are going to call it as, now what happens over here is, yes, so this is a hard strata. Then in this kind of condition, what happens is there is a possibility of, you see, observe to this rotation failure, and then along the base horizontal, and then a rotation failure. The compound failure means you observe whatever, this is nothing but the rotation failure, and this is going to be translational failure. What is the meaning of translation failure? Planar. This is going to be planar, right? And here it is going to be rotation. So if the type of failure is going to be planar, then you call it as a translation failure. And if the type of failure is going to be rotation, we call it as rotation failure. So this type of failure is known as a compound failure. Generally, we don't discuss about the compound failures because, see, it depends upon a lot of conditions. We don't go for the compound failures. Our main discussion is about the translation failure and rotation failure only. Now, the last failure, the last type of failure, wedge failure. Wedge failure. Now you see, if there is any hard strata located over here, hard strata located over here in stratified soils, we can see the wedge failure. If it is going to be hard strata and this is going to be loose soil, then what happens is this entire soil mass will slide. So then this is going to be soil wedge, and this type of failure is known as a wedge failure. So this entire soil mass, whatever the soil mass, will slide along the hard strata. So this entire soil mass will slide along the hard strata. Such type of failure is known as a wedge failure. Generally, we see in the case of stratified soils, layered deposits. So now, in given slope, in the given slope itself, if there is a stratified deposit, then we can say it as going to be a wedge failure. But commonly, we do discuss about two type of failures. The two type of failures are going to be, one is going to be compound failure. Sorry, the one is going to be transition failure, and other one is going to be rotation failure. And in the rotation failure also, who is going to be there? In the rotation failure, the failure is going to be due to the means in the rotation failure, the most common failure is going to be toe failure. So today what I have done is I have explained what are the type of slopes and as an engineer what we are going to do, and I have shown you some slopes and I said you what are the type of slopes, so finite slopes and infinite slopes. What happens, what is the example? Mountain slope and the soil slides downward and outside. This is a landslide, and in the case of here this is the rotation. And I said to you what are the factors that are influencing the slopes, and there are type of slopes and type of failures. I did not discuss the analysis. So with this, I'll be stopping for today. I'll say some things regarding to how to manage stress, and moreover, I'll be taking the doubt clearing session for now, because as I have not taken any doubt clearing session, I have to conclude the session by 1:20. So I'll be taking some doubt clearing session. Meanwhile, I'll say the preparation tips once again. So because once I start the stability analysis, it will take time. So as it takes time, I don't want to start now. I don't want to make you to hurry. It will take some time. So we'll see that analysis tomorrow. I hope you people are able to understand the class. Look, see, so far we have completed 14 chapters, and now the 15th chapter probably will be completing tomorrow, because once we go for that, so we have been discussing about these things from long period of time, and just an application you're going to see tomorrow, and this is going to be, and this chapter is also going to be a little bit formulatic, and I'm going to discuss those formulas tomorrow and how to remember those. And this chapter is important for GATE, not for IES. There was no much questions has been asked in IES. So only 10 questions has been asked from this chapter. If you look over all the previous GATE, sorry, all the previous IES questions are 10 to 11 questions only. So this chapter is important for GATE, not for the ESC. But anyways, I'll be concluding. I'll be looking over the points required for the ESC also. So now, I hope you people are able to understand the class, and sir, when would another test be held, sir? See, I know, right? I'm teaching this subject, right? When to keep the test and when to say stop, when to say continue. I know that, right? Wait. So meanwhile, see, I'm trying to make sure the questions are for you people, but I'm unable to. So because of the schedule, but I'll be trying to send at any cost by tonight. I'll be trying to send you some questions for your assignment purpose. Probably I'll send it today night. I'll send for chapter number 11 and chapter number 12 and chapter number 13 and chapter number 14, along with the solutions also I'll be sending today. So for the 4 chapters, I'll send the assignment and I'll send the solutions, because once the test series starts, we have to go with the test series also. So I'll try maximum. I'll try by today. By most possibility, I'll try to send at least 2 chapters by today night assignment, and along with the solutions also. And if there is a possibility, I'll send all those questions also. So please bear with me, because I too have some other schedules. I have to cope up with the remaining things. So test series were there, so it may take some time. So to be honest, you are the best. Thank you, thank you, thank you. Sir, please make some tricky questions and hard. I will. Don't worry. Yes. Now, how to overcome the tension? Okay. See, the most common scare now the students undergoes is this tension, anxiety, and in other words, we can say it as anxiety disorder also. See, generally, it's a common thing for all of us. It's a common thing for all of us. Just like when you have completed your examinations, I mean, not now, in the BTech level, after giving the examination, whether you fail or not, you don't, you don't worry about those. But in your childhood, in school days, so once you have written an examination, definitely you will wait for the results. And in the classroom, while the teacher is announcing the results, so our heartbeats are going to be goes like 144 beats per second instead of 72. So that's such type of things are nothing but the anxiety disorder. See, this is common, very common in people, just like a common sense, but the common sense is not common with all the people. So I don't know why they have kept the name for the common sense as a common sense, but let's take. But anxiety is common for everyone, even for me also. I'm telling you. So why I say for me also, because I have been the same situation. So while I was going to my preparation also, I was so anxious. Not only for that, even I say one thing. For example, see, while I was teaching also, if I want to introduce some new topic, if I want to introduce some new topic, and if I want to explain a new topic in different dimension, I always feel some anxiety inside of me. That anxiety is like whether the students are going to be able to understand the class or not. So that anxiety is there with everyone in irrespective of the gender and irrespective of the age. And right now, for most of you people, or for all of you people, let's say, so very few people, some 10 to 15% would be like a higher levels. I am not discussing about those. I am also a middle level. I was never a topper. I was never a topper. And during my school days, during my college days, or during my MTech also, I was never a topper. I was just above average. So most of the students and most of the people will fall into my category only. So if the people are going to be toppers, then they also goes the same situation. But I don't know about a topper. So as a average student, I can say, while going through these anxiety situations, right now, while you're preparing, your main point is though some of the students are approaching me, sir, I'm preparing and I'm studying continuously and I'm reading whatever you said. But while coming to the examination, I am not able to reach the expectations and I'm not going to get the answers. I'm going to do some silly mistakes. See, a few days back, I have conducted a test series. I mean, a test for the 10 chapters. And I hope most of the people has cleared very good marks. And there were a lot of people who know the answers and who know the procedures. And due to their anxiety and due to the lack of time management, they might got negative marks. And those people know the concept just like the other people. Those people know how to use the calculator just like the other people. But those people have one thing extra that is known as anxiety. I don't say it as a fear, it's just an anxiety. The anxiety lies is whether we can get the answer or not, whether I'm going to get the correct answer or not, whether I can finish the examination in time or not. See, the best tip that I do in examinations, and it has helped me a lot, and it do help me now also. While I was a student, what I do, while I was examination, see, you please try it. If you get helps with this, I'll be happy. What I did in my examinations, whether it's a BTech examination or GATE examination or any other competitive examination, what I have done, and even the classes also, what I do is, when I go for the examination, in the first 1 to 2 minutes, I don't do anything. I just take a deep breath. Just inhale and exhale. I'm not doing any meditation and I'm not saying any yoga over here. So don't sleep in between the examination. But what I do is deep exhale and inhale. These are one part of the yoga only. Yes, And but mind it, this is very important exercise to reduce your anxiety levels. And even when I get more anxious also, I sit calm and I try to exhale and inhale. So what is the purpose of this one, sir? Sir, when you exhale, you're going to take more oxygen. Mind it, when you exhale, obviously the entire oxygen will flow into our body and it will pass through your blood and immediately it will reach us to your nervous system. See, the most important and complicated thing is going to be our nervous system. Our thoughts are destructive thoughts. If you want to make sure yourself, make yourself. And you can destroy yourself with your thoughts also. So thoughts are just like that. You can make or you can break also. So when you exhale and inhale, means when you inhale more air, the oxygen levels in your body will increase and it will purify the toxins and it will enter into the nervous systems, which makes sure you are free of tension and anxiety. Even still, when I go to the classroom, I do say in offline classes also, if I go to the classroom every day, when I enter into the dais of a classroom, I do take at least 1 to 2 minutes of time. I don't go directly enter into the stage. If by entering the stage, hi students, how are you? I don't say that. When I enter into dais, the people who has taken already coaching so under me in the previous years, so those people can know. When I enter into the dais, I take some time. I first set the pins and I'll drink some water. I take some time. Meanwhile, what I do is exhale and inhale. I'm trying to make sure myself to be calm. This is the very simple exercise that you can go through. And it won't take much time. Just like you can do for 30 seconds also, you can do for 30 seconds or 1 minute. So that you can make sure yourself so calm and pleasant. And this is one point that I follow. And the second one is, no, I am not a topper. Seriously, I am saying I am not a topper. So, yeah. So the next one, first one is exhale and inhale concept. So whenever you feel like not only this one in your reality, in your real life also, when you stuck into this type of situations, so you please make sure 5 means 30 seconds. If you want to go for 10 seconds also fine, but the time I'm defining for you, but I do for 30 seconds to 1 minute. So you can define for 5 seconds or 10 seconds or 20 seconds. Number one. And number two, music. Number two, music. The most important thing, and I love the most, is this music. See, now due to the schedules or due to my timetable, I might not be able to listen the music in the morning. But during my college days, while I was in BTech or MTech, what I do is early in the morning when I wake up, I do listen songs. And you know what? I don't listen like well, I'm saying about mine. I do love soothing songs, which means slow songs a little bit, not like bumchik bumchik. So whatever the item songs. So means hard music. I used to love soft music where the lyrics are going to be more important than the music. So what I do is early in the morning when I wake up, say I have my favorite playlist with me. So I used to play the same songs in a loop, which makes me to feel pleasant. See, when your day is going to be start a pleasant way, I'm telling you that's going to be a very good day for you. Just imagine you wake up and you are going to get angry on someone. Then you feel, see, first of all, you get anxious. Why you become angry? And then you will become more anxious. Why you are going to getting the angry continuously? And then you are going to be anxious on yourself. Why you are getting angry on someone who is not part of your life? So this anxiety is going to be increases as you get angrier and angrier. Your anxiety levels are going to be increases more. So what I do, and this is one of the best solutions that made me to go through these years of hectic schedules and the stressful life. Yes, I have been undergoing a lot of stress while I was my BTech. So due to financial situations and personal problems, so a lot were there. And I hope you also know what you have done in your BTechs also, means while you're doing this one. So I do the second simple technique is I listen music. I listen music. People says that see, various people may have various perspectives. So people may says that so practice more, study more. But what I do is keep some space for you. Keep some space for you. You are an intellectual person. You represents uniqueness. And we are here, we can see the macro world and we can see the micro world. We can see the small jumps. Right now, coronavirus, a lot of technologies are working on that to know what is the ability of this corona, and they are working over the virus further, which means we are looking over a minute things micro, and we know the galaxy as a macro. See, with our small human brain, we have an ability to think into larger space and to penetrate into the small space also. So, my dear fellows, what I want you is just spend some time with yourself. And the best possible times that you spend on yourself is 2 times. Early in the morning, once you wake up. Second one, bedtime, just before you go to sleep. Just think yourself like just before the time that you're going to get into the sleep, and that time just you lay off in the bed. There is some time gap. The time you're going to be lay off on the bed and the time you're going to get sleep. And in between that small span of time, think about yourself, what you have done today and how you have been able to cope up with your anxieties. So these are some things that I follow, and I'm telling you, if these are, I'm not going to say big tips because I don't write any book or something else. These are from my personal experiences, and some people may have some other experiences also, but you do try it. Listen your favorite music. Whenever you get anxious, you try to listen your favorite music and try to be still and calm. Take a deep breath, exhale and inhale. If you can follow these two things, then definitely I'm telling you, you can get rid of your anxious levels in the examination also. And especially coming to the examination, so the first 30 seconds to 1 minute, take a deep exhale and inhale. And mind it, the world is not going to be in tomorrow. And tomorrow, sorry, the world is not going to be in today. And tomorrow there is a day. Work on it. And there is one famous quotation from the Abdul Kalam. Don't let your past to blackmail the present so as to ruin your future. So whatever happened is happened. Past is past. So you cannot change anything. If you have done right things, fine. If you have done wrong things, also fine. So you don't have much time to regret. Just focus, and you're going to learn something every day. Every day you're going to learn something. So stop regretting and start living. So don't think of the past and don't ruin the present by forecasting your future. So that's not going to be good for you. Live present. The present is the most important moment. But what we do is we always stuck our life in the past, and we always think what I'm going to do in the future. It's just like constructing a building without a foundation. It's just like constructing a building without a foundation. The foundation is present. Without a present, we cannot forecast our future, right? Well, don't worry about the result, end result. Forget about the gate result. Whether you are going to be all India ranked topper or pauper, that's defined at the end. But right now, journey is important. And enjoy the journey. Enjoy the work you are doing now. Do not stress up yourself much. And when you stress yourself much, then the stress is going to be stress you more and more, so that you cannot bear that stress and your strength is going to be less. You are going to be fail. As simple as that. So don't let anyone to compress you. Don't let anything to make you feel bad. You are the one, and you are the sole conqueror of your life. That's it. And if you are going to be able to know that on that day, on that fine day, you are going to see the things differently. The dimension that you see is entirely different. So please follow these things. Now I'll take some time for the doubt clearing session. So it's almost 1 o'clock. So I'll be taking, I hope you understood the 2 points. Please try to follow that. Then you can reduce your anxiety also. My dear one sir, songs winte examination hall lo ఆలోచించేటప్పుడు ఆ సాంగ్స్ గుర్తుకొస్తాయి. ఆల్రెడీ ఎక్స్పీరియన్స్ so many times me kuda. See, I said you don't listen the songs during the examination hall. Do listen the songs every day, means when you wake up, to make sure yourself pleasant, not to remember, and don't write your song lyrics in the examination. Yeah, so the people who wants to leave, they can leave. I'm not stopping anyone. The people who wants to leave, you can leave, and I'll be taking a small doubt clearing session. So why didn't you opt for GATE second attempt extra 1 year? But I believe you may ended being a PSC officer. No, I didn't want. I don't want to wait for 1 more year. So I'm enabling the options, doubt clearing session option. So raise the hand option. I enabled that. So please. What about my okay, fine. Please respond. How many days will be there in our logging details? I don't know. Okay, fine. Now let's see. Mr. Shankar, please speak out. Mr. Shankar, please speak out.
Hello, sir.
Yeah, Shankar, please raise your voice.
Sir, I had yes, sir. Hello.
Yeah, Shankar. Tell me.
I had
Speak out
page,
loud.
page number 71, question number 30, sir. Previous ESE.
Page number. Page number.
Previous ESE.
Previous yes. Page number. Tell me, please, once again.
71, sir.
70?
1. Question number 30, sir.
Number
Question number 30.
30.
30, 30.
33.
30, sir, 30.
30, okay. Laboratory vein shear test can also be used. Shear parameters of silty sand, no. And shear parameters of sandy clay, liquid limit of silty clay, plastic limit of clay. See, this is not going to be useful for this one. This is going to be useful for the sandy clay. Why, sir? Because the vein shear test is not suitable to determine the Atterberg limits.
Okay.
And you can use only for the corrosive soils, and instead of clay soils, if you use any soil mass with clay, you can use that also. So answer is going to be B.
Okay, sir. And one more question, sir.
Yes, tell me.
44th, sir, 73 page number.
Please, can you speak with a loud voice?
Sir, page number 73, question number 44.
Question number 44.
Yes.
Shear test on corrosionless soils, the initial void ratio less than the critical void ratio. You tell me. The corrosionless soil, 44, 43 or 44?
So 44, sir.
Yeah. As the state of strain of an element of dense sand changes from real strain, the effective angle of internal friction. You please tell me. See, in the case of the sand, you in dense sand during shearing, initially soil compacts. Means phi is going to be increases. Understood? And then soil will dilate. You please go through the previous means I have given you the notes. Then phi is going to be decreases. That is the reason why you see in the case of the volume change also, this is delta V plus and this is a minus delta V. If it is a dense sand, first volume decreases or not?
Yes, sir.
Yes or no?
Yes, yes, sir.
Which means compacts. When you undergo compaction, friction is going to be increased, and then it is going to be dilates. So dilates means a volume increase, then phi will be decrease. So in the case of the dense sand, what happens is the effective angle of friction first increases,
Then
and then it should decrease.
yes.
Okay, from plane strain to trivial strain. What is the meaning of here is from plane strain to trivial strain means this is the plane strain. This is the plane strain, and then as the soil will dilates, what happens to phi? So from the plane strain to trivial strain means, you see, this is the strain versus stress, and whatever is nothing but the plane strain, Nana. Okay, and whatever this is nothing but the critical strain. So in case of the dense sand, due to interlocking, see, it's going to be due to dilation. Interlocking breaks. So as the interlocking breaks, phi is going to be decreases. So the answer is going to be decreases.
Okay, sir.
Okay.
Okay, sir.
Yeah.
Thank you, sir.
And my dear anonymous attendee, sir, I am asking for what is mean by limit equilibrium, sir? Sir, I told the limit equilibrium every time, sir. Limit equilibrium means plastic elastic equilibrium. Okay, so in the case of the Coulomb's theory, the point where the failure is going to be happen is not peculiarly mentioned. So the limiting equilibrium, which is nothing but plastic equilibrium, is not be mentioned clearly in Coulomb's. So the meaning of limiting equilibrium is the plastic equilibrium. Here. Is there any other doubt? Mr. Shankar? Okay, fine. Next, let's take some other callers. Mr. Shankar, please unmute your voice, audio. Next. Miss Indu, please speak out. Miss Indu, please speak out.
Good afternoon, sir.
Good afternoon.
Sir, my doubt is regarding C5 backfill, sir.
Yeah, tell me.
In C5 backfill, due to cohesion, active earth pressure decreases.
Means if I backfill due to cohesion, active earth pressure decreases. Yes.
But in economical backfill, best suitable backfill, due to cohesion, active force.
Active pressure. We have to look over the force, right?
Yes, sir.
See, pressure means at every point, but force means the whole, whatever the force acting on the wall. The force is important than the pressure, right? The pressure change with respect to point, na?
Yes, sir.
At the top it is negative, at bottom it is positive.
Yes, sir.
While you are taking the force, you have to account the total force, and that force is going to be act at a height of h/3 from base, right?
Yes, sir.
And that force is responsible for the failure.
Yes, sir.
Okay.
Sir, but if you do, when compared with the cohesionless soil, Fa2 value will be less, no, sir?
Fa2.
That is, after formation of crack, active force will be less when compared to cohesionless soil, no, sir?
No. After the formation of crack, what happened is, what you're doing is you're neglecting the tension, right?
Yes, sir.
What is meant by neglect? Means what is meant by tension? Tension is positive.
Negative.
If you remove the negative value, then the result is positive or negative?
Positive.
Hmm?
Positive.
Then what happens over there? The active force is going to be increases or not?
Yes, sir.
Yeah.
Thank you, sir.
Yes. Any other doubt?
No, sir.
Yeah. Okay. Fine. Now, Mr. Mohit, please speak out.
Good afternoon, sir.
Good afternoon, Mohit. Tell me.
Sir, in 14th chapter, earth pressure,
Huh?
gate 7th question,
Gate 7th question.
1 marks.
Page number, please.
Page number.
Speak quickly.
Sir, actually, I have closed the PDF. So it's
Okay.
57.
Meanwhile, I'll be
57.
explaining. Huh?
57.
Yeah. Page number 57. Page number 57. So, right. Which question you want?
7th.
This figure, right?
Yes.
Yes. See, that requires the angle of inclination concept that I will be discussing at the end. So if you do discuss now also, it is not going to be, it means it will take a lot of time. You please mail me, I'll send the explanation for that, okay?
Okay. And
Yeah,
sir,
it requires a more circle concept and all those things, that's why.
and in shear strength,
Yeah.
chapter 18th question, 2 marks.
Chapter number 18, question 2 marks. I have already done this one and I have shared this one, my dear Mohit. You please go through the yesterday or day before yesterday's PDF. I was explained for one of our student and I have shared that PDF. I have shared in the PDF also. You please go through yesterday's class or day before yesterday's class. I think so, day before yesterday's class. You please go through that. You can understand. Okay.
Okay, and sir, one more.
Yeah.
Sir, in case of deviator stress, when we applied such kind of stress, can
Mr.
we?
Mohit, I am not able to hear your voice clearly. Please speak loud.
Sir, in case of deviator stress,
Yeah.
when we apply such kind of stress, can we tell the direction of shear stress in the soil mass? Means exactly it is acting on vertical plane or horizontal plane, something like that.
Yeah, and deviator stress is acting vertical plane. Means vertical stress acting on horizontal plane. What's the problem with that?
Somewhere I've seen such kind of question that the application of deviator stress on the specimen in case of triaxial test will produce shear stress on vertical or horizontal planes.
It's vertical plane. Sorry, it's a horizontal plane. This is a vertical horizontal plane. The vertical stress. Vertical stress acting on the horizontal plane, right?
Okay, okay, okay.
Okay,
Thank you, sir.
fine. Any other?
No, no, thank you.
Yeah. Now, meanwhile, page number 52, question number 13. The person who is asking the page number 52, question number 13, you please look over this. Yeah, that's field vein shear test. So now it's a was inserted completely in a deposit of soft saturated silty clay. See, completely in a deposit. Completely means the enter is going to be filled. Now they have given the vein, blade, and all those things. Now 500 mm below the ground. Upon application of the rapidly increasing torque about the vein rod, the soil was found to fail when the torque reached 4.6 Newton meter. So they have given the torque 4.6, assuming mobilization of undrained shear strength on all failure surface to be uniform and resistance mobilized on the surface on the vein rod to be neglected. What would be the peak undrained shear strength? Round off the nearest value, the shear strength. They have given the data to make you feel worry and scared. that's it. They're asking the undrained shear strength. They have given T value as how much? 4.6 Newton meter. 4.6 Newton meter. And you know the height of the vein, how much? 10 mm. And dia of the vein is going to be 50 mm because this is going to be height of the vein or length of the vein. And this is dia of the vein. Then T is equals to pi d square into Cu into h by 2 plus d by 6. So you want Cu, you can find it done. And next, page number 59. Okay. Page number 59, which question it is? Question number 8. What is it in it? Total active earth pressure per unit length. They're asking force, total active force that you can solve it. You draw the pressure distribution and then the top 3 meters is there. So you can find it out. Answer is not getting for that. Okay, let me see that. Okay, fine. I'll check that and let you know this question. So let me check this question. So now Cu is equals to T by pi d square into h by 2 plus d by 6. D value given as 50 mm. So D value 50 mm. So now let's convert everything Newton meter, right? So let's convert everything in terms of centimeters, and h value 10 mm, 1 centimeter, and now Cu is equals to 4.6 into meter. 1 meter is nothing but 10 square Newton centimeter by pi into 5 square into h by 2. H by 2 means 1 by 2 plus d by 6, 5 by 6. 5 by 6 plus 0.5 into pi into 5 square, 4.6 into 100 by answer. So which is going to be 4.39 Newton per centimeter square, and I can write 43.9 kilonewton per meter square. The answer is going to be 43.9 kilonewton per meter square. Let me check that answer. So this is question number 13. $43.9. Okay, fine. I'll look into that, and I'll get back to you. I'll look into that. And I'll get back to you. And for today, I am closing the session because it's already 1:23. So within within 2 or 3 minutes, the tab will be closed. So yes, for page number 59, the 8th question answer is not getting. I was trying the question more number of times. Mr. Damodar Rao, I'll see and I'll let you know for tomorrow. Okay, fine. And have a good day for you for today. And I'm leaving.